A confirmation regarding the audio, please. If you guys are able to hear me out perfectly well, kindly confirm the same. Thank you very much. We shall be starting in a couple of moments, guys. So, hello, a very warm good evening to all of you, and welcome to Baiju's Exam Prep. Welcome to today's session, where from today we shall be embarking upon a journey where we shall be covering the subject of geography in the next 24 modules. And one by one, we shall be approaching the various different areas of the subject and covering the subject. Now, having said that, when you think about the term and the subject of geography, many of the times we can safely say that it is not one of the favorite subjects of many of the candidates. While few of the candidates will swear to you that this is one of the most easily understandable subjects out there, but still, let us take it as an opinion that it is not very popular amongst the candidates in general. But when we talk about geography, geography is something which is going to be relevant in various different stages of your examination. So first reason why you should study that subject is because it is important for the exam. Now, let us understand, why is it that UPSC wants you to study geography? There must be certain reason behind it. After all, let's say, and you, I'm sure, would have that kind of a question in your mind that I want to become a civil servant, I want to become an IAS officer. Why do I need to take care of geography at all? So one has to understand that geography ends up shaping a particular region, shaping the history of the land, and also showing direction to the economic growth, the social customs, the cultural values, the traditional things that we hold closer to us. Almost anything and everything that you associate with in your day to day lives, there is geography involved in it. When you think about it, for example, any part of history that you consider, it has got an intricate linkage with the subject of geography. For example, think about it. When you read the portion of ancient India, medieval India, you would always have heard about the invaders coming from the northwestern part of the country. And if you ever sit down and ponder about it, that why is it that the invaders used to come from northwestern part of the country, you get the answer from the geographical facts and the geographical factualities of the country. That is, from all the other sides in general, you will find that there is a level of protection provided in the form of the mountains or the water bodies which are present there. It is in the northwestern extent where there is opening to the rest of Asia and also eventually to Europe. So that basically means that this particular area or the opening has been utilized not only by invaders but also traders of those times. And that is how the entire social milieu, the social customs that you follow, the food items that we consume in the entire region, that is a byproduct of that intermingling which has happened in that particular region. Have you ever thought about it that when you consider or when you study in history, for example, that the Europeans did invade various different South Asian nations and also did go on to colonize many areas, many island nations all across the equatorial area? Now, once they did manage to colonize those areas, they carried out plantation agriculture. Now, why is it that they wanted to colonize those areas? If you think about it, then all those nations of Europe which went ahead and which went for colonization, all those countries basically experience a 6 month of non growing season because of heavy snowfall that they receive. And as a result of that, they feel the necessity, or they have always felt the necessity, to preserve food for a longer duration. And one of the best preservatives which is out there is black pepper. And that is why black pepper, as one of the spices, was in huge demand, always in the greatest demand during the Middle Ages. And that is what the European traders came to this part of the world to get. Once they got that, they realized that, okay, we can make various utilities out of it, and hence geography again shapes up the history of the region. Now, if you think about it, then the political establishment that you see in many of the areas, for example, even in our country, you have various different regions awarded under sixth schedule of the constitution, where you have a kind of an autonomy provided at the local level. Now, if you notice the geographical realities of that place, that is a region which is generally something which you will observe is surrounded by hills and valleys on the side, which means that geography of that location has never allowed the people to intermingle freely from all around. So the people in that region would have been self-sufficient and would have had followed their own customs and traditions for centuries altogether. Again, geography determining the political setup. Now, the food that we consume, the types of fruits that we eat. Now, even those food items, they are grown only in certain parts of the country. You still feel the need to import many of the food items because many of the food crops, they get wasted. Here again, you have the role of geography. So in every and any facet of life, from your dietary habits to the historical past that we are proud about, everything has got a linkage and has got a genesis from this particular subject. That is why UPSC wants you to have a mastery over this particular subject. Now, if that doesn't convince you about the importance of this subject for your preparation, let us get empirical in our evidence. Let us try to quantify the relevance from the examination point of view. So, from this subject directly, in the prelims, in the prelims, you will expect basically close to around 12 to 16 questions. 12 to 16 questions appear directly in prelims from the portion of geography. So that in itself carries a weightage of around 30 to 35 marks, varying from year to year. So in general, you would be able to score around 24 easily. At least around 10 to 12 questions you will be able to get correct, provided you follow the basics, provided you stick to the course that is justifiable. Then, other than that, once let's say you qualify through the prelims examination, in the mains examination, the role of geography still continues. In the mains examination, you find subjective question coming in geography from the and appearing in the portion of GS paper 1. In GS paper 1, again you get around 7 to 8 questions having a total weightage of around 105 marks. Okay, direct questions from geography, they will come in the mains examination worth around 105 marks. So that is huge. And if again, I would say, if you are sticking to the basics, if you are regular in the session, regular in the classes, and session does not mean sitting in front of the screen thinking about all the various things that you can dream about and then eventually say that I have been regular for the 24 sessions. No, it is mentally being present at that point of time. So mentally you have to be present at that point of time. Okay, so if you are mentally present for these 24 sessions, in all these 24 sessions we shall be starting from the very basics of each and every individual topic, then we shall be approaching these areas. Now if you are doing that following current affairs, then out of these 105 marks, around 90 marks you can easily attempt. 15 marks I'm keeping on the side, let's say the unpredictability of UPSC, but then around 90 marks out of this 105 you can easily attempt. Other than that, the implied utility of geography is something that you will experience in the prelims, even in the portion of environment and ecology. In the portion of environment and ecology. So from the portion of environment and ecology, you expect close to around, again, 12 to 14 questions. Now, out of these 12 to 14 questions, your idea and knowledge of geography will help you solve close to around 4 to 5 out of these questions. Okay? For example, let's say you have a question with regards to a particular kind of an ecosystem, let's say grassland ecosystem. So what are the conditions which lead to the creation and the formation of grasslands? Those kinds of questions you can easily solve if you have studied geography, at least the basics of it. Other than that, in the mains examination, you will also find the utility of geography in the portion of disaster management, disaster management. How and why? Because think about it, what is disaster management? Management of disasters. What disasters are we talking about here? We are talking about floods, we are talking about cloud bursts, we are talking about tsunamis, we are talking about earthquakes, volcanic eruptions. Now, studying the subject will enrich your understanding about these different issues, these pertinent issues, and automatically you will get an idea about how to tackle these disasters. For example, when we study about the details of, let's say, earthquakes, we will study about the fact that in the case of the earthquakes that we observe or that we experience, in the case of earthquakes, you have a kind of a tremor which is felt around 1 to 2 minutes before the main earthquake. So that gives you enough of a warning signal where you can trigger your alarms and you can rush to safety. So your understanding about earthquakes will help you understand how to manage the disaster caused as a result of it. So there are multiple implications even in the portion of essay. Essay, where you are expected as a candidate to create two essays for the entire paper. Basically, you will have one of the essay topics where you can always put in the geographical perspective of an area. And sometimes you can have direct questions in the essays. For example, the geopolitical and the geostrategic advantage that India's location provides to it, sitting atop the Indian Ocean, then border management across the Indian borders which are present. So all these require an in-depth understanding of the subject of geography. So this is where you will have multiple implications. And it is not only restricted to here. Let's say you have qualified the prelims. Let's assume you have qualified the mains when you knock the doorstep of the interview board, even at that point of time. You will have the interview board asking you questions, for example, interlinking of rivers, agricultural growth and output, the types of crops that we can grow, the localization of industries in a particular region. All these again flow from the basics of geography that UPSC wants the candidates to study. So this is the importance of the subject as far as the exams are concerned. Now everybody knows this. All the serious candidates, they are aware about how important this subject is. If you consider the entire plethora and the gamut of different subjects that you have to study, amongst the major ones, geography does figure out. For example, along with polity, economy, and so on, you need to give almost equal emphasis to the subject of geography as well. So if everybody knows the importance of this subject, why is it that still many of us, we face difficulty in understanding this, in studying this? That is because, in simple terms, in very basic terms, many of the times we are not even aware about the approach to follow. So first of all, let us make ourselves clear with the aspect of what is the approach that one needs to follow while studying the subject. Is it like any other subject that we are studying, for example, economy, polity, etc.? No. The answer is plain and clear no. For other subjects, for example, let's say you are studying history. Whatever you have understood, you look at the book, you know there is nothing escaping your mind, and whatever you have to learn eventually is going to be present in the book. This is where geography tends to play with the candidates. Here, this subject has got intricate concepts involved in various different portions, and everything follows a kind of a pattern. There is no randomization which you will find in this subject, that randomly a cyclone has occurred in a place, or randomly a region has experienced, let's say, a tsunami, or randomly Turkey has experienced earthquakes. No, it all happens as per a due process. And here the candidates have to understand that process. You need to have the understanding of those concepts. Once you hold those concepts closer to you, then you will not need to revise the subject ever again before the exam. That is where we falter. Where we falter is we initiate the subject with a kind of a gusto and kind of an enthusiasm that is almost unparalleled. And that is something that I find with most of the students who are present there. Immediately they will start talking, okay, tell me the books that we have to cover, tell me all the portions that we have to cover. From today I will start covering it. There is so much amount of impatience in the beginning, but after 3 to 4 days, when the concepts they start coming in, that is when people panic, and that is when the reaction comes, okay, if there is so much difficulty in gulping that, let us study something which is more interesting. Let us study maybe about the aspect of modern history or ancient history. Let's see what the kings did. So there is a kind of an escapist tendency. And then again, when you rehook yourself back to the subject, by that point of time, 5 to 6 different concepts would have passed, and then you will find it incredibly difficult to catch on with the incoming concepts, because each of the concepts which are present in geography, for that you need a base, and thereupon you build upon the complicated and the most complicated systems which are present around us. Here you have to realize that for this subject you don't need that particular amount of importance being given to the book. Having said that, you do need to study the book, but you have to understand the surrounding around you. That in itself can be a great teacher of the subject. The moment you step out of the house, the moment you look up into the sky, sometimes you see that there is a cloud cover but there is no rain. Sometimes you observe there are light clouds and there is in turn a very heavy amount of downpour. Sometimes you experience sudden movement of very strong winds, and sometimes there are thunders and lightning storms which happen. All of this is nothing but the subject that you have to study. UPSC, in the notification that it issues, it has mentioned very simply geography of India and the world. That is it. UPSC has not described it very elaborately in the notification. It is how we interpret it based upon the past questions which have appeared. How do we approach that? That is something we will see. Now, first of all, start with the aspect of classification of the subject. Now, here, when we talk about it, then in the classification of the subject as per the notification, you will find geography of India and the world. Now, rather than studying it as the aspect of world geography and then classifying as Indian geography, where you will have to do the repetition of many concepts time and time again, we will be classifying the subject into two portions. And that is where we will be dividing it into the portion of physical geography physical geography, and then Indian geography. In the portion of physical geography, what lies in that? There we'll study about, first of all, the land that we stand upon, the interior of the earth structure, the mountains that we see around us, the earthquakes that occur, the volcanoes that erupt. That is something we'll study under the portion of geomorphology. Geomorphology. That is something where we will study the patterns and we will take the example with the help of the world. We'll try to understand the world with the help of the concepts. Time and time again, we will be taking the reference of various different parts of the world, various different continents in place. Why is it that, for example, Andes are situated across the western edge of South America? Why is it that Rockies are situated across the western edge of North America? And is there a pattern to it? That is something we study in geomorphology. Then, after that, we will be studying the portion of climatology. In this, as you can expect, we will study the atmospheric condition, what the atmosphere is made up of, what are the impacts of various different components on our day-to-day lives, what are and why is it that different phenomena they are triggered and experienced, be it, let's say, a tropical cyclone, be it, let's say, what we refer to as a bomb cyclone. Why do we experience hailstorms, snowstorms, thunder, lightning, jet streams? All those aspects we shall be studying in the portion of climatology. Sometimes you would have experienced that it is a summer day and still in the evening you have significant thunderous amount of rainfall with large ice particles also falling there. Even though your area is very warm and hot, still you will have those ice particles and ice balls falling. So why does that happen? So in every case, we will be studying the why, where, and the how of it, along with the examples of the world, which helps us understand the world better. Once we have completed these two, then we will be studying the portion of oceanography. Oceans of the world. And how is it that in the region of the Atlantic, the water ends up moving? The water mixes between the Atlantic, the Indian Ocean, and the Pacific Ocean over a period of 1,000-year cycle. So that is something we shall enrich our understanding about. And once we have basically cemented these conceptual areas, these are the basic concepts which will stay with us for a longer period of time. Once we have managed to cement this area, then we proceed to the portion of Indian geography, where for the syllabus, what is relevant is physiography, that is the Himalayas, the Deccan Plateau, the Thar Desert, the northern plains, the island territories that we have. Then climate of India, climate of India. Then river systems, where we'll study about the aspects of interlinking of rivers and so on. River systems. Then agriculture, or rather we will start with the portion of soil and forests. Then we will study about agriculture, minerals and industries, and then we settlement and transport. Eventually, we will dedicate a module to study about maps. And there we will find a strategy regarding how to cover maps. That map session is not going to be per se that I will dictate to you that mark this point and you will mark this point on a blank piece of paper. No. We will talk about how to develop that ability. Throughout this journey, we shall try to develop that kind of a critical thinking to approach a subject. That shall be our basic aim and goal. Along with understanding of the concept, our effort should be and would be rather to create a kind of a peripheral view of that concept. For example, let's say we are studying about the aspect of the interior of the earth. Now, how that interior of the earth has come into existence, what are the impacts that it has on our day-to-day lives? And for example, when we talk about, let's say, solar storm, then what is the impact of solar storm on our day-to-day lives? So that kind of a critical thinking has to be developed by you. Please understand that in this examination, I hope that we are all here with our eyes wide open. I hope you are aware of the challenge that befalls in front of you. So let us cover this subject in the best possible way, in the easiest possible way. And for that, you need to keep your portion of materials that you refer to the minimum limited amount. Now, the portion of current affairs is also relevant to the subject of geography, and it is this portion, Indian geography, where you will get and find areas dealing with current affairs. So many of the times you have a particular current affairs issue in discussion or in prominence, and you find a related question appearing in the examination. So that is where the current affairs also has to be kept in mind. Now, when we take a look at the material list, first of all, these are few of the basic materials that you can have. So start with the most basic of the material, that is the NCRTs. Ideally, for gaining a mastery over this subject and fulfilling the requirement for general studies, please keep in mind, for general studies, for the coverage of geography for the subject of general studies or for the portion of general studies, the basic NCRTs are more than sufficient. And here, NCRTs of class 11th and 12th. Classes 11th and 12th NCRTs, you have many NCRTs. We'll start with the physical portion of geography, and then we will move on into the Indian geography and other aspects of it. In case you are finding the understanding of class 11th and 12th geography difficult, which should not be the case ideally because it is written for students of class 11th and 12th. So obviously, this is something, if written for school kids, I'm sure you will not find much of a difficulty. In case you are still finding it incomprehensible, then in that case, you can refer to NCRTs from class 6th to 10th. In case you are not able to understand the portion of 11th and 12th, then further go from class 6th level, start reading the books, and I'm sure class 6th level books is something that you can easily conquer. Now, this NCRT you can cover, or it is an or, not and. Or you can cover the book provided by us, the Byju's book that you have. There also you can study that. Or you can study from NCRT. Any of them would do as the source of material for the subject. Along with that, you will be given the PPTs of the session and the additional reading materials. Okay? PPTs and the portion of additional reading materials, that is something which will be provided to you. And thereby, with the help of these, you can carry out your daily revision process. And please understand, and I'm sure you have the videos available with you as well. You have the tablet lectures as well, which are available with you. Right? So you can revise with the help of these videos as well. You can enrich your concept. The focus here has to be to understand a concept to the root. It is not about mere coverage of a chapter, that I've read this chapter from point A to point Z, that means the chapter is done. No, it is not a reading exercise that slowly it will come into your mind. Each of these chapters have various different concepts. Once you are able to imagine that, once you are able to put that in your mind that how this could have unfolded or how this would have taken place, then your understanding will be much better and much prolonged. Now then, we know that Byju's book is a kind of optional with NCRTs, any of them. Then World Atlas is going to be one of your best friends for your preparation and your entire preparation journey. Now, why and how to use World Atlas? Before that, many of us, I think, it won't be wrong to assume that many of us, we are not aware about the utility of map pointing or what kind of questions are coming in the portion of map pointing, or why do we need to cover maps for the portion of geography. How many of us are not aware of that? Please be frank and let me know. How many of us are not aware or not sure that what to do with maps or what kind of questions appear from the portion of maps? Fair enough. So here, let me be very clear when I say that for general studies, you don't get a question for map pointing. Please understand, when we say map pointing, what is a map pointing? Map pointing is you will be given a map will be provided to you, and you will be asked to point a location like you used to do in your class 6th, 7th, 8th, 9th classes at that point of time. So that is map pointing. For general studies, again, I will repeat, you get no questions, you get zero questions for map pointing. There is no question for map pointing in general studies mains examination. In optional, you are provided with a map where you have to point out few places. In general studies, there is no such question. Then why does the world make so much noise about maps, geography, and understanding geography with maps, and paying attention to maps, learning the maps? Why does the world make so much noise about it? That is because time and time again, UPSC tends to ask one or two questions in the prelims which are slightly associated with the portion of mapping. For example, in 2022, UPSC had asked a question that which amongst these nations they are not a bordering state of Afghanistan. Now, when UPSC asks the candidate this question, do you think the UPSC expects out of you that you as a candidate should be aware of all the various countries and all the various boundaries which are there? Absolutely not. That is something which you cannot even expect from a computer. So that is not the expectation of UPSC. Then why is UPSC asking this question? That is because Afghanistan has been in news. Afghanistan had been in news last year because of the troop pullout by the NATO forces. That is why Afghanistan was in much discussion, much prominence. So UPSC asked a question with regards to Afghanistan. There again, UPSC asked a question with regards to the South China Sea and disputed islands between China and Japan, the Diao Senkaku Islands. Now, when UPSC is asking this question, does UPSC expect out of you that take the atlas and start learning all the small islands which are there? Absolutely not. This is where the candidates falter. This is where they start going wrong. They look at the question and they start with the blinkers on. I hope we are aware what the blinkers are, where you cannot see side to side. So with the blinkers on, they have the focused attention that all these factual questions which are there, I will learn it up. And that is when they go wrong. That is when they have no clue what to study, what not to study. If you can recall, those of you who are aware, in 2018, UPSC asked such a random question. That is, it asked for the location, the relative location of Delhi, Hyderabad, Pune, and Nagpur. Which of these are situated closest to the same longitude? Now, UPSC had asked this question in 2018 or 2019. It was probably 2018. Since that year, I know many candidates who keep on learning all the major cities across the longitudinal order, across the latitudinal order, but UPSC has not repeated that question. UPSC has achieved what it wanted to. It has forced you guys to change your preparation strategy and thereby surprise you in the process. So that is something you have to be mindful of when you devise your preparation strategy. World Atlas is not to answer the questions directly. World Atlas is your window to exploring the world in which we live. So this World Atlas, when you think about, this is something which has to be approached very exploratively, because as a candidate, I'm sure all of you, none of you rather can claim that you know the locational aspect of each of the countries, each of the water bodies, each of the continents, etc. I'm sure none of you know that. But whenever you find it in current affairs that a particular disputed island is in question, or a particular city is in question, or a particular country is in discussion, that is where you need to go back, open up the atlas, look at the location of it. Once you understand the location of it, then many things become clear. For example, once you understand that Russia and Ukraine war, you have Turkey, which is an important negotiator there. Why? Because close to Ukraine, you have the Black Sea, which opens close to Turkey. So Turkey holds the key to the trade. So that is where the location of the countries that you will explore, that is something which will make your life much easier when it comes to understanding of this subject, when it comes to understanding of the peripheral areas and your overall perspective development. So World Atlas should be looked at on a regular basis. Regular basis. Okay? On a regular basis, you have to look at the World Atlas. And then comes the newspaper. Newspaper is an absolute must. Now, regardless of howsoever you frame the question, that I am looking at this analysis, I am taking care of this analysis, I'm not reading the newspaper, I'm doing this, that is why I'm not reading the newspaper. The minister is coming to my house telling me the news himself, that is why I'm not reading the newspaper. The editor of Hindu is living in my house only, that is why I don't read the newspaper. Regardless of whatever might be the excuse, newspaper is a must. Newspaper reading is something you cannot ignore and still expect yourself to be successful at the end of the day. Newspaper reading is much more than the portion of current affairs. The sooner you realize it, the better it will be for your preparation. Newspaper, many of the times we think that it is only for the current affairs, and we are basically mastering current affairs from the magazines, from the other areas. Why to read the newspaper? That reading habit, that reading ability, that is something you catch on. It improvises your understanding, your writing ability, and gives you a larger picture of what is going on in the world. And that is the kind of mentality and attitude which is needed out of a candidate, and a candidate who aspires to be successful in this endeavor. So newspaper reading is an absolute must. You cannot, under any circumstance, ignore the reading of the newspaper. Okay? Now, this is about the resources. Now, many of you would also have bought the books of G.C. Leong and Majid Hussain. Many of you would have bought this book, and you would have bought it because the market would have said so. There would be so much discussion in the market that buy these books, buy these books. That is why you might have bought it. Let me tell you upfront, if you are studying this subject only for general studies, you don't need these books. Understand the basic aspect. G.C. Leong has not been written keeping civil services in mind. G.C. Leong is a specialized book only for the portion of physical geography. That is something which is not needed for the examination. NCRTs, basic NCRTs are more than sufficient. Okay, when you read a book, read the NCRTs or the book provided by Byju's. Any of them is more than sufficient for general studies. Okay, so please don't indulge in multiple different books and exploring multiple different areas. So how to approach these classes, how to approach them, and how to understand that the subject in a better way. So basically in the class, we shall be taking the approach of looking at each and everything with the help of an image, with the help of a diagram, so that there is a visual recollection and a visual understanding as well. As I told you, the better or the more you are able to imagine the subject, the better this subject will be for you. So that imagination part will be created by the image form or the visualization form of study that we are going to follow. Now, while the classes are going on, I would basically advise you to pay maximum attention in understanding the subject, understanding the concepts taught. Here and there, you might find few of the concepts which are dicey, few of the concepts which don't make sense. So you can always ask the question. You will get the additional reading materials, ARMs, where all the things that have been discussed in the class, you'll find the definition format of it as well. Wherever you find something which is important, you can note it down. If need be, make running notes. But In the name of making running notes, please don't be such a candidate whose head is permanently tilted to the book or the copy and they consistently keep on writing, because thereby you end up missing the concepts that we are going to refer to the next, and you will always be playing catch up, and this will be very stressful experience for the class, which I don't want you to have. I want you to sit there in a relaxed atmosphere, and obviously not sleep enough, but then in a relaxed atmosphere sit there and try to understand. The better you understand after the session, you can revise with the book, you can revise with the additional reading material, you can revise with the tablet videos, any of them which is convenient for you. And then after that, make topic based notes or topic wise notes. One topic that you finish, make your own notes without looking at the book, without looking at any material. Try to write your interpretation of what you have understood. That will improve not only your writing skill, it will help you in answer writing as well, it will help you in revision as well. So that is how you have to approach the note making aspect as well. Okay. For optional, this is not the book that these are the very basic books, and for optional you need different books altogether. Harisha, is there any need to read NCRTs even after attending all sessions? Ideally, see, I would say no, because in all the sessions we are covering the NCRTs, but I would still advise you to refer to the books once at the time of revision. Please don't be under the opinion that you are attending the sessions now, and if you are appearing for 2024 or 2025, please don't be under the impression that just attending this session will be more than sufficient for you to clear the exam. You will have to carry out your own self study. Unless and until you internalize the concept, it will never be sufficient enough. So for that, many of the times you do require books, because you find a visual medium written there. In order to write what you have understood, that is where you need that kind of a material. That is why I'm suggesting the book. Okay. When should we start making notes for this subject? Actually, I would suggest, Shashank, the mercy running notes, anything that you find important in the class which is mentioned briefly, you can note it down here and there. But immediately after that, I would suggest to you that basically once you have covered a topic, and we will cover various different modules, various different topics, once you have covered a topic completely, after that, make topic based notes. So the understanding, or rather the approach to study, should be that we will approach it topic wise. One by one, we'll take a topic, and first of all, we'll understand the concept. Then we will understand the application of that concept, right? And then we will take a look at if any exceptions are present. If any exceptions. Okay. So that is the approach you need to take. And always, I would suggest, for a subject like geography, which oftentimes can become very strenuous for many of you, I would always advise you to make it more visually based study, where you are looking at the images or the pictures, so that you have a real time recollection and a relation that, okay, this kind of a feature leads to this landform getting created. So that approach works all the time. Okay. Uh, Priyanka, geography as a subject for civil services examination, I feel is too boring and I don't feel like doing it. Okay, interesting way to complete it. See, that is what I have been telling you. Try to relate your experiences in your day to day life. Have you ever thought about it that when you step outside your house and during the daytime, when you touch the road surface, it is very, very hot? Whereas the walls of your home, they are slightly cooler. Have you ever thought about the reason? And if yes, then have you ever thought about it that this particular reason is at play even in the region of Arctic Ocean, due to which the entire world is talking about the increased melting of Arctic ice? So the moment you are able to relate your daily experiences with the larger things going on around the world, that is when this subject becomes much more relatable. Otherwise, it will seem as if you are studying some theory of some far off planet, and you will try to gulp it down so that you can vomit it properly on the paper, and then the subject will be very torturous for you. That is for sure. Okay. Preetham, the language is very simple, my friend. The language is class 10th level language, my dear friend. Okay. Right now, all those who are referring to the various different, let's say, when we talk about current affairs, how to study current affairs with the aspect of geography in mind, as of now, do one thing: close that mentality that I have to extract geography information from current affairs. As of now, just stick to the portion of current affairs. After 2 to 4 months, you will start realizing that the portions of geography are also coming in. For example, the problems that we face due to urban population or urbanization in a country, that is something associated with geography. You have an upcoming industry located in a region, that is something associated with geography. You have newer tech which comes in the field of agriculture, associated with geography. You had the recent earthquake in Turkey causing a lot of death and destruction, that is associated with geography. So, the more you study and the more you are at one with current affairs, you won't be needing anyone else to tell you to distinguish that. That is something which will automatically come in. Okay. Byju's current affairs is enough, more than enough. For those for whom it is on the optional subject, then I'm sure that this is some area of general studies which you will find incredibly easy to digest, right? We'll talk about it, Sahil, whether earthquake can be predicted or not. If yes, why? If not, why not? Okay. Devansh, you can study the NCRT after the modules are over. Along with the NC, all those of you, I let me save some amount of your energy and time. Before you are typing in the question that I'm following DNA or analysis on a daily basis, still do I need to read newspaper? The answer is always going to be yes. As I told you, regardless of whatever you is going on in your life, newspaper reading is a habit that you should not leave. Okay, and rather you should develop that habit. I'm sure very few of us right now have this habit. Please develop this habit. It will make your personality better. It will make your communication skills better. It will make your answer writing better. Okay. And Preetham, what to do next? Attend the session, my dear friend, with an open mind. Let's see. And we will try our level best to make everything comprehensible, everything consumable. Okay. And let me tell all of you, before I'll take a few of the more questions, that from today we will initiate the subject. Let me lay out few guidelines for you as well, because you are also attending the session. You are also going to expect something out of the session, isn't it? It is not as if that I did not have anything good to do in the evening. That is why I'm sitting here in front of the screen and staring at this person mumbling away. I'm sure you have much better things to do. You are here because you want to clear the exam. So that goal should be there in your mind, that I have to clear this exam. We are not here to become doctorates or researchers in the subject of geography. I'm sure that is not the prime focus. That I'm going to prepare for civil services. Eventually, you never know that I might become a meteorologist, if not an IAS. I'm sure that is none of your aim, and nobody has that aim. So, we are here to clear the exam. So, whatever is required for a pinpointed focus to clear the exam, we will be doing that. Okay. So, that is something which should be there. Secondly, there are going to be in the entire journey across 24 modules, especially in the initial 12 modules, there are going to be certain areas and certain points which are going to serve as a hiccup. And let me be very clear, There are going to be certain areas and certain concepts in those 12 modules which you might find slightly on the tougher side. Have patience. Many of the times, the more that you read, the more in depth, in greater detail that you study, the previous doubts, they get cleared automatically. And I will show you the instance in the class as well. Today, when we are going to talk about the basics of the planet, I will read out to you the questions that you guys put forward to me. And then I will read out to you the questions that you guys put forward in the 23rd class or the last class. You yourself can analyze the change in your level of understanding. So be patient. It is always easier to rectify a weaker portion in a subject as compared to what many candidates do. Okay, this subject is something not interesting. Let me study polity once more, or let me study history once more. If you do that, you are left with the entire subject that you need to cover again. And that is a time you will never get back. So, ideally, I would suggest, even if a couple of topics make you slightly uncomfortable, hold down the fort, and surely and slowly and steadily you will have a better understanding as you get a wider viewpoint, as is the case in the preparation of civil services. The more subjects that you study and the more number of times that you revise, your understanding of the world around you develops in a deeper manner. That is something which is going to be here in geography as well. From your side, I expect certain minimum things. What are the minimum things? That after the session, please revise with the annotations or the additional reading materials or the PPTs what has been covered in the class. Please do revise that, because in every class we shall be taking up or assuming the condition that none of us know anything about that particular topic. So we shall be starting from the very base. But once we have covered the base, next time when we come to that, we will be laying bricks over the base. We shall be developing further concepts. If my understanding of heating and cooling is not correct because I have not revised it, under no circumstances can I understand the concept of air pressure. So that is where just revise what has been done in the session. Your next day's session will be easier, and that is something we can ensure from our side. Now, what to expect from my side or our side? Basically, I can tell you, if you are regular enough with the class, mentally attentive in the class, following what has been done, regular with the additional reading materials and so on. And again, when I say regular with additional reading materials, does not mean that I'm downloading it every day. I'm keeping it in a dedicated folder, and that folder's name is UPSC preparation. Under that, I have the section of polity, economy, history, etc. All of them consist of additional reading material. One fine day, I will open up those and I will say, no, this has to be done on a daily basis. If you put in that effort, that bare minimum effort of 30 minutes after the session, more than sufficient for this subject. Okay? Right now, we start. Okay? So here, when we start with the subject of geography, we will be starting with the portion of geomorphology. That is where we shall be initiating the subject. Now, today, we are going to discuss some of the basic aspects of geography, and then slowly and steadily, we shall be building up on that concept. Now, please don't mistake it from the fact that today, if we are dealing with the basics, this is not relevant for exam. UPSC has asked questions from this in the prelims as late as even in 2019. So you can have questions being asked from this. So when we talk about it, first of all, we need to have an understanding in the portion of geomorphology. We need to have the understanding of the most important system which houses us all, and that is our planet, that is Earth. That is the requirement of geomorphology, and that is the study of geomorphology, where we study the interior of Earth, we study the internal layerings of Earth, we study about the various different land movements, and so on. But that entire study of the planet, that in itself will be rendered slightly incomplete if we don't know the formation of Earth. So that means we need to have some idea about formation of Earth. Because if we are aware that how the planet got created, Our understanding about what goes on in the planet right now, what are the minerals that you find in the planet in different areas, that understanding will get simpler, isn't it? For example, let's say the road being constructed near your house. Now, if you want to understand the quality of the road, just by looking at it on the first day, I'm sure you won't be able to figure out whether it is a good road or not. But if you observe the building of that road, you will be able to understand whether that road is built in a good standard or a bad standard. And if it is of a good standard, that means it is going to be stable for a long time. If it is of a bad standard, means it is going to deteriorate in the near future. Means what? In order to predict the future of the road, you need to understand the past. That is the flow of process that is dictated by time. Similar in the case of planet Earth. If we want to understand where the minerals are present, why is it that the planet has a shape like this? Why is it that the planet is continuously moving around the sun? We need to understand some part of the formation. Now, formation of the planet Earth, that happened close to around 4.5 billion years ago. That is when the planet got created. That is when our entire solar system got created. Now, our solar system got created around 4.5 billion years ago. I hope we are aware that when we talk about solar system, we mean the sun and the 8 planets which are present around the sun. How many planets are there, by the way, around the sun? I hope we are aware about the number of planets. Good. I put out the answer, but still many of you have said 9. So Pluto is no longer considered a planet. It is only 8 planets. I hope that we are aware of that. Now, how did these planets come into existence? What are the various processes which have happened for the planet to come into existence? That is something we should know. Then, if we start tracing it back, then we know that the solar system that we live in that the sun that we look at, the sun which provides us with all the energy, that sun is nothing but a star. The stars that you see in the night sky, our sun is also a star. Now, what do we mean by a star? Stars are basically large, bulky bodies and objects where you have nuclear reactions which go on inside them. And that produces so much amount of heat and so much amount of light that we can see in the case of sun itself. Now, if the sun is a star, sun appears to be very bright and big, whereas the stars, they appear to be absolutely minuscule and small. Just a moment. A confirmation regarding the audio, please. Audio and video is clear. Good. So, as I was referring to, the sun that we see is a star. Then, the sun that is visible to us is so big and so bright, and the stars are something that we should stare at the night sky. That is because those are very far away. But the stars that you see in the night sky, they would also have the planets moving around them, just like you have Mars, Jupiter, Saturn, and so on moving around our sun. So the sun is a star. Group of stars, thousands, millions, and billions of stars. They make up what? What do the group of stars, what are they referred to as? Very good. They are referred to as galaxies. Galaxies. And our solar system is present along with many other stars. Where? In which galaxy? That is the Milky Way galaxy, right? This is something you would have heard since your childhood days. That is Milky Way galaxy. So if you consider the size and the shape of the Milky Way as a group of stars, a conglomeration of stars, an accumulation of stars as this. Let's suppose this represents the Milky Way galaxy. The sun is situated and the solar system is situated somewhere along the sides of it. So our sun is amongst the millions and the billions of stars which make up the Milky Way galaxy. Many of these galaxies, when considered together, that is what makes and creates the universe that we talk about. So, the image that you see, that image basically gives you a sneak peek into the universe. All these small things that you see, the shiny objects, these are not stars, by the way. All these small ones that you see, these are nothing but distant galaxies. All of them. Difference between star and planet. See, star will always be able to produce its own light and heat because of the nuclear reactions going on. Planet is something which is bound by the gravitational pull of the star, right? So that is the basic difference. So you'll find that many of these galaxies, they together make up a cluster, and many of these clusters, they together make up the entire universe. Think about it. This is the size, this is what you see as a galaxy. Just like that, you have one of those as Milky Way galaxy. Imagine if this is the Milky Way galaxy, our sun would be present somewhere hidden there. So that gives you an idea about how small and insignificant we are when you consider about the entire universe. But mankind's understanding about the universe has not always remained the same. Mankind's understanding of the universe has varied across the ages and across the years. First of all, when humankind would look at the sky thousands of years ago, and they would look up at the sky and they would see the sky as a rounded appearance is what the sky gives you the visual of, isn't it? When you look up straight into the sky will give you an appearance as if it is in a dome of sorts, and you will have stars. So first of all, early humans, they thought that we are living inside a giant sphere and that is what we see. Obviously that was incorrect. But mankind has always been fascinated about their own position in the entire world. So that is when people started observing that the sun rises up and sets. Sun rises in the east, sets in the west. And that gave an idea in the mind of the explorers and the geographers at that point of time that the earth that we live on, that might be the center of the entire universe, and the sun keeps on moving around the earth. That was the earliest understanding of the universe. That kind of model of universe put earth at the center of the universe. And that is why that model of universe is also referred to as the geocentric model. Geocentric model of universe. Okay? Where earth is the center of the universe. Obviously, over a period of time, this was proven to be incorrect. And then slowly and steadily, people came to the realization that, okay, earth is not the center of the universe because earth is moving around the sun. So that means the sun might be the center of the universe and the entire universe moves around the sun. That was the other explanation provided. So while geocentric model of universe was trashed, it was discarded, other model was picked up which told us that sun might be the center of the universe. That was something which was referred to as the heliocentric, that is sun at the center. Heliocentric model. This was also proven to be incorrect, but it was proven to be incorrect at a much later time. During the 1600s and the 1700s, that was our larger understanding, that sun is present at the center of the universe and the planets, they move around the universe. For us, in the 1700s, the universe was only the solar system. We did not even have the understanding of the entire galaxy, let alone the entire actual observable universe. So, the initial proponents for the theory of origin of universe, that is Kepler, Laplace, when they provided that theory for origin of universe, they basically ended up providing a kind of a theory which sort of tried to explain the formation of the solar system, the origin of the solar system. It is a different matter altogether, but that their theories did not stand true even in the case of solar system, but that is how the early models and theories used to be. You had various different theories which were provided that how this universe could have come into existence. Eventually, in the 1900s, you basically had an experiment which was conducted by the astronomer and the explorer with the name of Edwin Hubble. Edwin Hubble, he devised a telescope. He was an American meteorologist, an American astronomer, basically. And with that telescope, he would observe the universe. Now, while observing the universe, Edwin Hubble noticed something very unique. He noticed that all the various players in the universe that he is able to see, all of them are moving away from each other. All of them are expanding. It is moving away. Not that it is being attracted by something else, but everything is simply moving away. So Edwin Hubble said that look, the universe that we are living in, that universe is getting inflated, that is expanding. And the analogy which can be provided in this case is, think about a party balloon that many of us we used to put in our childhood days for the birthday parties and so on. You had the printed balloons, isn't it, where you had a lot of different polka dots and so on, which would be present and printed on the balloon, right? Now, while the balloon was deflated, you would see that all the dots, they lie next to each other. But the moment you blow air in that and the balloon starts inflating, that is the point that you will realize that all the prints, they are moving away from each other. So a kind of a similar analogy was also provided for the universe, that every object in the universe, that is expanding, that is moving away. So that is something which was propounded as theory of expanding universe. The theory of expanding universe. That is something which was provided by Edwin Hubble. Now, based upon this theory of expanding universe, you had a finding given by two scientists or meteorologists, that is Lemaitre and Gamow. Lemaitre and Gamow. Now, these two scientists, they had basically put forward a kind of a theory about the origin of universe, which was satisfied, or which was rather fulfilled by this theory of expanding universe. So then the world started taking attention that, okay, these two fellows, Lemaitre and Gamow, what is it that they had said? They had put forward their own theory for the origin of universe. And the theory that they had put forward, that theory was referred to as the Big Bang Theory. Not the TV series, obviously. Most of us are aware about that. So this is the most acceptable theory. And this is the theory which stands the test of time as well, in the sense that over the years, you have had various different findings and researches which support the theory. So this is the theory which tells us about the formation of universe. So what is this theory about? And what do we know about this theory? And what did they talk about? So they said that, look, as of now, everything in the universe is expanding. So if I interpolate that, if I basically assess that piece of information or analyze that piece of information that everything is expanding, that means sometime in the past, things would have been closer to each other. That is why now they are far away. They are still moving more far away, right? So if two objects, they are moving far away, that means sometime in the past, they would have been here. That means sometime in the past, they might have been even closer. So these guys, they said that, look, everything is moving far away, but that means sometime in the past, everything would have been much closer together. And at that point of time, everything that we see around us, the entire universe that we see would be contained in a small mass, one individual small mass. Now, this small mass is what they refer to as singularity. This is what they refer to as singularity. That this single mass, it had very high temperature and was present at very high pressure. Very high temperature and very high pressure. Means what? Means there's a lot of pressure and the temperature, the heat is also very high. Would mean what? It would explode. So this single mass which was present, and it was present in this state, it is estimated for only a few seconds, but it eventually exploded. When it exploded, materials, they started moving away from each other. Everything was vaporized. Such was the temperature. It is expected that the temperature would have been in the range of around 10 to the power 32 degrees Celsius. So attach 32 zeros in front of one, and then think about that those many degrees Celsius would have been the temperature. It is estimated close to around 15 million degrees Celsius would have been the temperature, much more than that. So thereby, at this point of time, in that high temperature, when the explosion would have happened, everything vaporized, everything. So you had a cloud which was created, and then that started expanding. With expansion comes what? A natural cooling. Things started cooling down. And when things started cooling down slightly, that is when you had the formation of electrons, protons, neutrons, and atoms were created. Hydrogen and helium, the lightest of the atoms that we know, they got created. And still, the entire material was expanding. Now, these helium atoms, they started reacting with each other, and that produced nuclear reaction, nuclear fusion, and that produced a lot of heat, a lot of energy. So that is how the first stars, they started taking shape. And slowly and steadily, galaxies came into existence. And then you also had the star in the form of sun, which was created. And this all happened around 13.7 billion years ago. That is when the entire phenomena took place. Now, this event 13.7 billion years ago, that is something which triggered the formation of the galaxies, the stars that we see around, and the sun, and also the solar system. That is why around 4.5 billion years ago, the Earth also came into existence. So that is the aspect of the Big Bang Theory. Before repeating it again, let us go through the written part of it so that some part of it is internalized. So this theory basically was born out of the observation that other galaxies are moving away from our own at a great speed in all directions, as if they had been propelled by an ancient explosive force. That means all the various different galaxies, they are consistently moving away from each other, as if there is a force driving them away. Right? Now, around 13.7 billion years ago, everything in the entire universe was condensed in an infinitesimally small mass, that is singularity, a point of infinite denseness and heat. That is the genesis of the entire universe. Now, suddenly, an explosive expansion began, ballooning our universe outwards faster than the speed of light. Imagine materials moving faster than the speed of light. As of now, we don't have any material which moves faster than the speed of light. At that point of time, the impact of the explosion was so huge that every material was moving away from each other at the speed of light. So that is where you had the genesis. And this is the representative image of the timeline of the Big Bang theory. Timeline. Now understand this. So this is the phase of singularity. Okay? Singularity, which is around 13.7 billion years ago. Right? Roughly 13 to 15 billion years ago. That is something which is present in singularity. It exploded. And if you observe within few seconds, 10 to the power minus 43 seconds, 10 to the power minus 34 seconds, 10 to the power minus 10 seconds, and 1 second. So within 1 second of that explosion, observe the amount of expansion which had happened already. The temperature of that infinitesimally small singularity at that point of time was around 10 to the power 32 degrees. In 1 second, because of that expansion, it came close to around 10 to the power 10 degrees. Right? Slowly and steadily, that loss of temperature continued. Slowly and steadily, atoms started getting created, molecules started getting formed. And once the atoms and molecules came into existence, nuclear reactions were initiated, and that is how the stars were born. Multiple stars formed up various galaxies, and eventually the galaxies and the star systems, they gave rise to the planets, and that is where we come in. So that is the kind of, in a way, the scaling of what we are and what the universe has been. So we have been present on the universe for a very brief amount of time, only for a few thousand of years. That is something, the universe has come into existence for billions of years. So that is where you know your position in the universe. So before we talk about impacting the universe by our good deeds, by our ideas, first of all, we should know our place in the universe. We cannot impact the solar system, let alone the galaxy, let alone the universe. Okay? So, simply put, when we talk about Big Bang theory, it says that the universe as we know, it started with an infinitely hot and dense single point that inflated and stretched, first at an unimaginable speed and then at a more measurable rate over the next 13.7 billion years to the still expanding cosmos that we know of and that we see today. So that is the Big Bang theory. Okay? So basically, again, I will repeat it in a very crisp manner. You had the origin of the universe was thought about by looking at the galaxies, how the galaxies are moving away. So this was observed for the first time by whom? By Edwin Hubble. I've written in the PPT. So Edwin Hubble for the first time observed that all the galaxies are moving away from each other. So based upon that, he gave the theory of expanding universe. Now that theory of expanding universe basically was utilized by Lemaitre and Gamow to further, with evidence, prove the point of the theory of Big Bang. That is, they said that, look, all the galaxies are moving away from each other, means at one point of time in the history, these galaxies would have been much closer. Much more time in history, they would have been much closer. If you take back time significantly, then around 14 billion years ago or around 13.7 billion years ago, all these would have been reduced to a very small particle, which they referred to as singularity. And they said that, look, this small particle would have had so much amount of energy, so much amount of heat that it exploded. And as it exploded, the materials, they started spreading. And that spread basically cooled down the temperature slightly, due to which the atoms started forming, molecules started getting created, stars were formed, and that movement or that expansion is still something which is continuing. So that is the aspect of the Big Bang theory, which is the most acceptable theory as of now. Okay, you don't have any significantly newer theory which has basically come to replace this Big Bang theory. And our understanding of the universe, which has been further increased by the presence of various different telescopes which have been installed in the orbit, they give us an idea about the galaxies which have been created long time back. Now these galaxies, they are, or these star systems, they are present very far away from us, very far away. So that distance between the stars that you measure, you oftentimes would use the term light year. What is light year? Light year is a unit of time or distance. What do you think? Light year is a unit of time or distance? Good. It is the unit of distance. It is basically the distance traveled by light in 1 year. That is what is referred to as light year, right? So when we say that a particular star is, let's say, 32 light years away, when we say that it is basically 32 light years away, means what? It has taken 32 years for light to travel from that star, right? So we are, with the help of the telescopes, now the most powerful telescope that we had launched in the orbit, that was named based upon the name of Edwin Hubble. So for a long period of time, the most powerful telescope which was present was the Hubble telescope. With the help of the Hubble telescope, people would be able to look at far off galaxies who were present at millions of light years away. Meaning what? That the light which would have been emitted from that galaxy, we have received it now, and that had originated millions of years ago. So might be that the galaxy would no longer be existent anymore, and what we are seeing is the past, what has happened millions of years. So with the help of these telescopes, we are able to look at distant galaxies, but in other words, we are able to look at the past. Now this Hubble telescope has been replaced, and you have the more powerful modern telescope which has replaced it. And what is the name of that modern telescope which has replaced it? Good. That is the James Webb telescope. It is, as of now, the most powerful telescope which gives us an idea about the galaxies which are situated even billions of light years away from us. Now, if a galaxy is situated, now think about it, apply your logic here. If a galaxy is situated 5 billion years away, or 5 billion light years away, means the light that we are seeing right now, that light would have started its journey 5 billion years ago. That means before the planet even came into existence. So that gives you an idea about the scale of the universe, about how huge and how large this universe is. In that universe, we do have our own star, and that is the sun. Around the sun, we have the planets which keep on revolving around the sun. And why do they revolve around the sun? Attracted by the solar gravitational pull. It is because of the gravitational force exerted by the sun. That is why the planets rotate. And if you have to understand this, think about it with the example. Suppose, let's suppose you have a ball in your hand or a pen in your hand, this pen. Now, if I hold it above the ground and if I simply let it go, what will happen to the pen? The pen, as you can see, simply falls, isn't it? So, what is that force? Why is it that the pen falls? There must be some reason behind it. What is the force responsible? There is one force, that is gravity. Right? In the case of gravitational force acting, the object simply falls here. Now, suppose you have the same pen or the ball in your hand, and let's suppose you give it a push. You throw it with a certain amount of velocity, let's suppose. Now, when you throw it with a certain velocity, what do you do? Or what do you experience rather? When you throw this, it will follow a trajectory, but it will fall nonetheless. It will follow a trajectory like this. Now, what if I put in more amount of velocity, more speed? Then what will happen? If I put in more speed, it will fall maybe here. Isn't it? So, owing to the gravity and the gravitational pull, that is why the object falls. Now, use it on a larger scenario. Suppose this is the sun, and suppose this is a planet. Now, sun is many times, hundreds of times larger than the planets, right? So sun will attract those planets. There will be gravitational pull. The planet will tend to fall just like the ball above. The planet will also try to fall. But imagine that this planet has got a velocity, a significant speed. Then what will happen? This planet will follow a trajectory. All the meanwhile, it will try to fall on the sun, but it will follow a kind of a trajectory. It will reach or arrive somewhere here. Right? Now, here again, if you observe from another angle, this will be attracted by the sun like this. It will tend to fall on the sun, but it has got a velocity. So, if you then invert it like this, it will then again try to fall, but inadvertently reach here. Again, the solar gravitational pull will try to pull it closer to itself, but then again, it has got a velocity, and that is when it manages to reach here. Again, there will be gravitational pull of attraction. Again, the velocity will carry it here. So it is the gravitational pull. If the gravitational pull would not have been present, the planet would have escaped somewhere else. The planet would have simply moved on and simply veered off and wandered off in the path. But because of the gravitational pull exerted by the sun, that is why all the planets, they are continuously attracted by it, and that is why they continue to move around the sun. Just like this, the other stars that you have, many of those stars, they have multiple planets in existence, right? Many of the stars that you see in the night sky, they have their own set of planets which keep on moving around them. So, what these planets are made up of is basically a kind of a remnant, what was left behind after the formation of the sun. When helium then started reacting, and there was a nuclear reaction which undertook, which produced a lot of heat, that suddenly swept off many of the dust particles which were present, and the remnant portions, they started forming planets. We'll study that with the help of the formation of Earth, that we'll study in the next module. Now, that is the motion of planet Earth, and that is the motion of planet Earth around the sun. Now, here, once we are aware of that, then let us try to understand few of the facets of planet Earth's movement around the sun. Now, planet Earth continues to move around the sun, right? Now, here, if suppose, now obviously this image is wrongly placed, but if suppose you have the sun here, if suppose you have the sun here, now sun is going to give light, right? Now it is going to light up which portion? Only the portion which is exposed to the sun. The areas which are not exposed to the sun, they will not receive the light. So that is where you will observe a kind of a line, an imaginary circle, obviously, where one part of it does not receive the light, the other portion of it is lighted. So this imaginary circle that you have this as imaginary circle. So this imaginary circle that you have, that is what differentiates, in a way distinguishes the areas which are lighted, the areas which are not lighted. Now the areas which are lighted, lighted by what? By solar rays. So when you receive the sunlight, it is daytime. And when the areas which are not lighted, there you observe nighttime. So it is in these areas where you experience the day. It is in these areas where you experience night. And this imaginary circle is referred to as circle of illumination. Circle of illumination. So that differentiates the regions experiencing daytime and nighttime. So, what do we experience on a day-to-day basis? On a daily basis in your life, you would observe that early in the morning, we experience the sunrise. And later in the day, we experience around evening, we experience the sun to be setting as well. Isn't it? So, what is that? That is basically the planet which is rotating. As the planet rotates, different areas, let's say this is the sun, as the planet rotates, different areas they get exposed to the sun, and eventually after that they are hidden from the sun as well. So when they are exposed to sun, that is when we observe the sunrise. And again, when they go into hiding at the backside, that is when we experience nighttime. So the rotational motion of the planet, that is what gives rise to day and nighttime that we experience. So that is your portion of circle of illumination and rotation of the planet. Okay? How planets have the velocity and how it got velocity, the Earth to rotate. So basically, see, the planets, they have the velocity since the time of their very formation itself. The formation of each of the planets that you see, that is something which is made up of multiple hundreds and thousands of collisions, billions and trillions of collision. Initially, you had small particles. These started colliding, increasing in size and colliding much more. So we will study about it when we talk about the formation of the planet. But that is how those multiple collisions of the already moving dust particles, that is what provided that natural acceleration to the planet in question. And that is why it continues to move around in a rotational and a revolutionary motion. Why did the sun not get any velocity? Sun has a velocity. If you can think about it, if you can expand your thinking about it, remember I had shown you the position of sun around the Milky Way. And we had talked about the fact that sun is not even at the center of Milky Way sun, and the solar system is somewhere on the side. So just like the case of the planets moving around the sun, you have the sun moving across the Milky Way as well. So the sun keeps on moving at significant speed, hundreds of thousands of kilometers per hour, and you have the planets hooking on and being attracted by the sun and thereby continuing the revolution. So you have all the movements taking place simultaneously. Okay, right? How planets revolt. Planets don't revolt. You have people who revolt. Why will planets revolt? Day and night. Okay. Day and night that you see is basically because of revolution, or rather rotation of the planet. So that rotation of the planet that you see, so planet keeps on rotating from west to east. We are talking about planet Earth. So they keep on rotating around the axis from west to east, and it is again aided by the gravitational motion of, or the gravitational pull of attraction. So because you have that gravitational pull of attraction, you have, let's suppose this is the planet and here you have the sun. So even this particular area of the planet will be attracted by the sun, so it will try to come and face the sun, right? So in the process of doing that, this particular portion will actually be sent behind, and then this portion will have that kind of an attraction. This portion will try to face the sun. So this is a kind of a continuous motion which results in a rotation. Vijay, we have already explained Big Bang Theory 3 times, my dear friend. What is the problem in Big Bang Theory? Please try to ask that. Basit, that is what I have been talking about, that planets, they rotate because of the gravitational pull, and that is what initiates the rotation, and then you have the angular momentum of the planet which catches up. Different parts which are away from the sun, they will try to get towards the sun, and that is how the entire rotational process is initiated. Vijay, that is what I have been asking you. Which portion of Big Bang Theory you have not understood? Are you able to hear my voice, Vijay, or is it just the question that you are typing? Darshan, no, black hole is something which is completely different. Black hole is very, very different from singularity. Black hole is when you have the star which dies and it gets converted into a dark energy matter which has huge amount of gravitational pull. So that is where you have even the gravitational waves which are, so that is a different concept altogether. Universe has n number of galaxies, yes. Okay, Vijay, listen to it carefully this time. Try to understand it. All the various different things that we see in the universe, many of the stars, they make up galaxies, right? The sun is a star. All these stars taken together, they make up galaxies. Now it was observed that all these galaxies, all the stars, they are continuously moving away from each other. So what was thought about it, that now when they are moving away from each other, at one point of time they would have been much closer to each other, and when they would have been much closer to each other, that means they would have been very close, very close. And if you take back time significantly, at one point of time, it would also have been a single mass. So that single mass is referred to as singularity. And that is where, in that singularity, you would have had so much pressure, so much of temperature, that there would have been an explosion. And due to that explosion, things started moving around and they are moving away from each other, and that is how eventually atoms got created in the process. Those atoms created molecules of helium, hydrogen. These helium molecules, they started interacting, creating the stars, and slowly and steadily other elements in the solar system and the universe also came into existence. Okay, I hope, Vijay, that is clear now. Why it is referred to as a circle of illumination? That is because it differentiates the area which is lighted and the area which is dark, hence the name circle of illumination. Gravity decreases with increasing distance, always. Gravity is inversely proportional to distance. In fact, Newton had also said that with our mere fingers, we will have a gravitational relation with the stars as well. But the reason that the fingers and the stars don't interact is because of the large distance. Any two objects, if they have significant mass, they will have that gravitational pull associated as well. Abhishek, that is because we move along with that. What is the nuclear fusion reaction in the sun? That is when you have basically two small atoms, they react, that is two helium atoms, they react, and that is when they produce enough light and energy, and this process keeps on happening. Okay? Then we come on to the portions of Earth as a rotating planet. But before that, we'll take a break. Inside each galaxy, yes, there are many groups of stars. We'll take a break. It is the first class today. Let's not torture you guys beyond a point. So we'll take a break, guys, and be back. Wash your face, hit yourself, whatever is required to keep yourselves awake and up. Do that. We'll take a break. Today is the first class. So let's take a break of 15 minutes. Okay? Relax. Come back in 15 minutes because I hope that many of you would still be confused and still would have your mind in the stars. Bring that back in 15 minutes. We will continue. Okay? A confirmation regarding the audio, please, guys. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. Then, many of you have put on many questions. Why velocity of Earth wasn't become zero, Ravindra? Why will it become zero, my dear friend? Think about it, that why will the velocity become zero? At that in outer space, you don't have anything which will slow down the speed. So there is no reason why it should. Due to velocity, the planet doesn't fall in the stars. But how they got the velocity in their starting period? That is basically because the initial formation in itself, that is where you had many small particles leading to the formation, and those particles were again in motion around the star because of the gravitational pull of attraction. So that is where the collisions which were initiated, that brought about a kind of a spin as well, and they brought about a kind of a movement as well. Okay. Shweta, how did they predict how much temperature was reduced in 1 second? So that is based upon the calculation, Shweta, based upon the calculations that we observe from the distant galaxies, the very far galaxies which were formed much earlier. When we observe that, we get to know about how they would have been created. And that is how we can basically extrapolate and interpolate the data that, okay, going back in time, that would have been the temperature. Shiv, that image that you see, it is representative. The expansion has happened in all direction. Baldev, heliocentric model has been completely replaced overall. That does not stand true anymore. Right? That heliocentric model used to be present when people thought that sun was the center of the universe. Now we know that there is no such center of the universe. Basit, the sun keeps on moving as well. Yes, my dear friend. Is it velocity or centripetal force that moves the planet? Centripetal force will never act on a static object, Abhinav. Centripetal force acts only on objects which move in circles. So it is that velocity which provides that circular motion, and that is when the centripetal and the centrifugal forces they come into the picture. Why can't we feel the speed of Earth? The reason is very simple, my dear friend. Think about it, that basically, suppose what the average height of humans, let's say. So let's suppose you are a very tall fellow. Let's suppose you have a height of around 6 feet, 6 feet 2, 6 feet 3, maybe. Still, your height will be how much? Around 1.8 meters. What is the radius of Earth? Radius of Earth is 6400 kilometer. So something which is present at a particular, and that dimension is 1.8 meter. Think about it, that how large the planet is in comparison. So even if the planet rotates or does not rotate, we are too minuscule to even feel that any effect that is present. Okay. Yashika, how many times do we have to read the NCRTs? As many times as you can, till the materials are drilled in your mind. There is a lot of gravitational force in space depending upon which object is attracting the other one. Yes, Devansh, that is true. Why do we feel earthquake? We will come to that in the third or fourth module. Have patience as of now. Okay? No, Tanu, that is not important. Okay? Right? Now, Now we come to the basics of planet Earth as a rotating object. Now we do know that the planet keeps on rotating around its axis, right? And it rotates around its axis from the direction of west to east. That is a continuous rotation that the planet goes through. So, one rotation takes how much amount of time? Close to around 24 hours. That is what constitutes one day. So, in one day, the planet manages to complete one rotation from a direction of west to east, right? So, here, basically, the Earth spins on its own axis from west to east. And it takes the Earth close to around 24 hours to complete one full turn or one full cycle, as you refer to it. Okay. Now, here, just a moment. Okay, an announcement with regards to the feedback form and the feedback sheets that have been rolled out to you. So, you have attended various sessions till now. I think you would have attended modern history, you would have attended the portion of post independent India as well. So, whatever your experience has been, please fill in the feedback sheets, and that is something which you are required to do. Okay, right? Now, then coming back, so Earth continues its motion as a rotating planet. Now, the speed of rotation. So think about it. You have a kind of a sphere which is rotating at an incredible speed. Now, if you imagine it with the help of an image, a diagram, think about it that this is the planet, let's suppose. Now, this planet is rotating, right? So that means this area is also rotating. That means if I consider this area, let's suppose this area is also rotating. If I consider this area is also rotating. And if I consider this particular portion. Now, let me name this position as A, B, C, and D. Now, one rotation takes how much time? It takes one day. So, time to complete one rotation is one day. Time for one rotation is how much? Is one day, right? And speed is equal to what? Speed is equal to distance by time. Isn't it? Speed is equal to distance by time. We know that time is equal to one day. Now, let's suppose I want to calculate the speed at which the various different places they are experiencing the rotation. Let's suppose I want to find out the speed of rotation at A, the speed of rotation at B, speed of rotation at C, and speed of rotation at point D. Now, for all of these, what will be the formula if we consider one rotation? It will be distance traveled by time. Time is 1. So here this will be distance covered by A divided by time. Time is equal to 1. This will be distance traveled by B divided by time. Time will be 1. Distance traveled by C divided by time. And this will be distance traveled by D divided by time. Now look at this particular image. Now, in order to complete one full rotation, if let's say you are at place A, your friend is at place B, your another friend is at place C, and another one is at D. So, in one rotation, which of you will cover the maximum distance? Who will cover the maximum distance in one rotation? The person at A, B, C, or D? What do you think? Maximum distance during one rotation. Very good. Most of you are absolutely correct. So the person who is placed at A, that person would have covered this entire distance, where let's say the radius is r. So the distance that he would have covered is 2 pi r, right? The value of r keeps on reducing, so the distance traveled would be less. So can we say that distance traveled by A in one rotation will be greater than distance traveled by B in one rotation? That will be greater than distance traveled by C in one rotation. We can say that because as we move from A to C, we are talking about smaller circles. Now, what about D? What will be the distance traveled by D, which is situated at the polar region, if we carry out or if we count one rotation? What will be the distance traveled by D? What do you think in general? Beautiful. There will be almost zero, because it is a kind of a point on the pole and the entire planet is rotating regardless of how many rotations it undertakes. That position D will be placed where it is. The planet can keep on rotating, but in one rotation the distance covered by D is equal to 0. So now if I put all of these into this formula, can I not come at the conclusion that speed of rotation at A will be greater than speed of rotation at B? That will be much greater than speed of rotation experienced at C. And that will be much greater than as compared to speed of rotation at D. And because the distance traveled by D is 0, so that is why speed of rotation at D will be 0. So that means we can also think about it that when the planet rotates, the maximum distance covered in one rotation is at the central point, that is the equator of the Earth. That is where it covers the maximum distance, right? And it covers the same maximum distance in the duration of one day. That is why we say that the speed is maximum at the region of equator. As we move around to the region of poles, the speed of rotation reduces to 0. So basically, speed of rotation at any point upon the equator is at the rate of approximately 1600 kilometers per hour or 1000 miles per hour. Approximately 1600 kilometer per hour. Right? So, decreasing to 0 at the region of the pole. So, the speed of rotation is maximum at the region of equator and keeps on reducing as you move to the poles. Why? Because the distance covered in one rotation, that also varies as you move from equator to the poles. So this is one of the factors, one of the concepts that will come in handy when we study about the oceans, that we study about the wind patterns. We get an idea that all the winds, they end up bending as they move north or south. All the oceanic waters also bend. Even the missiles that you fire in the air, they also bend because of the rotation of Earth. So that is something, all those concepts we shall be covering on later. That is why you should be aware that speed of rotation is maximum at the region of equator. Now, what is the real time implication or application of this? This is a factor, or this is one of the factors which is used, and the understanding of this is used in order to carry out the launch of satellite vehicles. So this part is utilized for the launch of satellites. How? So, for launching of satellites, for rockets, etc., why do you strap on a rocket to a satellite? So that you get enough amount of speed. The rocket is there, and burns off because you need speed, right? So the greater speed that you have, the better ability that you will have to launch heavier satellites as well, right? So in order to achieve greater speeds, that is why you attach rockets to the satellite vehicles. Now, around the region of equator, the speed of rotation is fastest. So to make use of that additional speed, that is why majority of the satellite launches that you observe, they are done closest to the equator, right? That is why majority of the satellites of satellite launches happen closer to equator. That is where you will observe that those countries who do not have their territories around the region of equator, even in those countries, you will observe that they end up launching the satellites to the southern part of the country. For example, take the case of United States. United States, you will observe that carries out or manages its satellite launches from the southern states of United States. That is from Texas or from Florida. That is where they are launching the satellites, right? So even in India, you have those launches happening from the southern part of Andhra Pradesh. So even in portions of Kerala. So that is where you have the satellite launches closest to the equator. Take the case of France. Now, France is known for launching very heavy vehicles, very heavy space vehicles, very heavy satellites, right? And you have the French space agency, that is Ariane Space, basically, that also manages to launch these heavy vehicles and heavy satellites. Now, you would observe that none of these satellites are launched from the country France itself. That is launched from where? It is launched from the country in South America, which lies almost at equator, that is the French Guiana. And from the region of French Guiana, you will observe that the satellites are launched. Why? Because it is closer to equator. Okay? Now, after this, see, satellite launches basically they require higher speed. In order to escape the gravitational pull of the Earth, they require higher speed. So, for higher speed, you attach rockets. For greater higher speed, you will try to launch at an area which already has a speed of rotation, so that if I launch something, it automatically gains that speed. So, that is where you try to launch it closest to the equator for it to be able to gain that required speed as well. Okay. Harshita, but all the points rotating togetherly with the then why their distances are different from each other. It is very simple maths, Harshita. For a point of time, use your mind and listen to this carefully to understand that aspect. What is the distance covered in a circle? It is the perimeter. So suppose I consider a place at equator. Let's suppose this place A. Now, in one complete rotation, A will cover how much distance? So, distance covered by A, let's suppose the radius of Earth is considered by R. So, distance covered by A will be how much? 2 pi into R. That will be the distance covered by A. Now, somewhere in the northern part, let's say, we consider another point, that is B. Now, it will move across this circle with a radius R. Suppose here you have B. So what will be the distance covered by B? Distance covered by B will be equal to 2 pi small r. Now, just by looking at these images, big R is greater. So R is going to be much greater than small r, isn't it? So can we not say, because R is greater, 2 pi and 2 pi are constant, can we not say that distance by A will be much greater than distance by B, covered by B? Isn't it? So even though planet Earth is not a circle, but someone who is, let's say, standing at the place B, you as an individual, you are standing at a place B, your friend is standing at a place A. So what is that distance that your friend will cover in one day? That distance will be counted by or calculated by what? By 2 pi r. In one rotation, that is the automatic distance that that person will cover. So that is why, as you move closer to the poles, the speed of rotation tends to reduce. Think about it. Whenever you, even if you have globe at your house, then if you try to rotate the globe, observe that the ends of the globe, they are almost constant in their position, as the region around the center that rotates with faster speed. You will observe that the ends, they are comparatively still slightly slower. And that is why when a circle is rotating, at the center, you will have the maximum rotation. As you move closer to the apex, the rotational speed reduces, and that is also the case with planet Earth. Okay? Right? Now, then we come to the revolution of the planet. Planet Earth revolves around the sun in an elliptical orbit. It is attracted by the gravitational pull of the sun, and that is how the planet Earth revolves. Okay? Galileo was the one who invented telescope. Then why Edwin Hubble said, okay, are you aware that at what point of time, generally, even if you give me the answer in centuries, I will still be satisfied. At what duration of time did Galileo end up finding the telescope or discovering the telescope? The one who has written this question, and for others as well, that when Galileo came up with the discovery of telescope, when was this? Which era are we talking about? Yashika, what do you think? Galileo, did he live along with us? Does he belong to our generation? No. He belonged to the 15th and the 16th century of discoveries that happened, right? The 1600s, the 1700s, the 1600s were particularly influenced by Galileo. And when you talk about Edwin Hubble, when he made that discovery, that was in 1920s. Right? So it is similar to saying that if I say that there was this individual who covered the entire road from Kolkata to Khyber Pass, you would say, but that road was built by Sher Shah Suri, then how come this person has traveled? Galileo made that telescope, but hundreds of years later, people, they used that telescope to find that. So can you give the credit to Galileo or the person who found that? So think about it logically. Okay, is that clear? Right? Anish, just like humans, rocket is also a minute object when compared to radius of the earth. That is true. Since the speed has since the speed has no effect on us, how will it be helpful while launching rockets? Okay. So why we talked about our own scale and our own height overall is, we are not launching into the space. We are not trying to rotate around the earth. The satellites are. The satellites are continuously moving around the earth, so they have to be placed in the orbit. If you place the satellite on the ground, why will the impact of rotation or revolution be felt? But if you want to launch that satellite beyond the or in the orbit of the planet, then you need to provide that velocity, right? That extra push. Otherwise, try jumping on your feet. Look at how high you can jump from the ground surface. Will you be able to jump even for 1 meter? No. Then how will you reach that level of so many kilometers up into the atmosphere? You need some speed. Where do you get that speed? You attach a rocket booster to your back, light it up, and maybe then you can rise up. Still, if you don't have enough speed, that is when you make the use of rotation. Okay. Is the gravitation of Earth is only situated at poles? Absolutely not. Right. Now, coming to the revolution of planet. In all the places, Galileo is known as father of the telescope. I am nowhere saying that Edwin Hubble is known as the father of telescope. No, please don't misquote me in that. I have never said that Edwin Hubble discovered the telescope. Edwin Hubble utilized the telescope to make that findings. And it is with the help of those findings that Big Bang theory was postulated. Okay, so please don't get confused. Right? Now, then we come to the revolution of the planet. The planet keeps on revolving around the sun, aided by the gravitational pull of attraction of the sun, and thereby it moves in different places around the sun. Now, the planet is continuously tilted on its axis. Tilted on its axis means that it gets varying degree of solar light as well. How is that? So, let us try to understand it with the help of an image here. Suppose, let's consider this to be the sun. Now let's consider this to be the planet Earth. In one position and in another position. Right? Now in all these places, the tilt of the planet is going to be the same. But it can have a completely different implication in these different positions. How is it so? We'll understand that. This is the equator. This is the equator. Now here, you will observe the oncoming solar rays. Okay, here also, you will experience the oncoming solar rays. Right? The solar rays come in. Now, these solar rays are what will give the light, isn't it? They will create a circle of illumination. Now, how will that circle of illumination look like? Basically, the portion exposed to sun, that will experience daytime, and the portion which is hidden from the sun, that will experience nighttime. So, can we not say that here this entire area that will be hidden from the sun? Can we say that? The planet is rotating continuously. The planet, meanwhile, is rotating continuously in a direction of west to east. In a direction of west to east. It is continuously rotating. But here, can we not say, in this case, the first image in position 1, that this area will experience night and this area will experience day. What about the other region or the other position of the planet? Suppose the planet is situated here in the earlier one. So here, if we draw the circle of illumination, can we not say that this is the area which will be hidden from the sun? Regardless of how many rotations the planet takes in this location, those are the regions which will be hidden from the sun. So these are the regions which will experience night. And these are the regions which will experience day. Isn't it? Now, Observe these two areas. So here, the equator ends up dividing the entire planet into two halves. And those are referred to as the northern half and the southern half, or the northern half sphere or northern hemisphere and the southern half sphere or the southern hemisphere, because the planet is in a spherical shape. So the equator divides it into northern hemisphere and the southern hemisphere. Now, in the first position that you observe and the second position in comparison, now if I consider this as the northern hemisphere and the southern hemisphere, so in the first position, that is here, which receives more amount of sunlight? Is it the northern hemisphere which receives more sunlight, or is it the southern hemisphere which receives more sunlight? What do you think? Very good. Beautiful. It is the southern hemisphere which is more exposed to the sun, right? But then, if I take you to figure number 2, in the case of the figure number 2 that you observe, which hemisphere will observe more sunshine? Is it the northern hemisphere or the southern hemisphere? Very good. Northern hemisphere. So, while in position 1, and if you compare it to position 2, the tilt is the same. The tilt has not changed. The direction of the tilt has also not changed. It is just the position of the planet along this region of the sun, which means different areas are exposed differently to solar light. Now, in this situation, that is when, in the condition of 1, because the southern hemisphere experiences more light, more solar rays, that means it will be summer season. And simultaneously, the northern hemisphere, because it is receiving sunlight in a very small area, and that too for a small time duration, because very quickly that portion will be hidden by the circle of illumination. So that is why it experiences sunlight for a very short duration. Lesser sunlight experienced. Yes, Preetham, that is correct. And this is what we experience as the winter season in the northern hemisphere. So that is why when you have winter in the northern hemisphere, you will observe that the countries in the southern hemisphere, they experience a summer season, right? Simultaneously, if we consider the position 2, now here in the case of northern hemisphere in position 2, it will experience more solar rays or more sunlight, and this will lead to summer season. Summer season. And this will lead to shorter, or this is the southern hemisphere. So this will lead to what season in the southern hemisphere? Winter season. Winter season in the southern hemisphere. Generally, the conditionalities that you see in 1, that is something which is experienced during the months of October, November, January, up till around February. And these conditions that you see in figure 2, that is something you experience for the months of April, May, June, and some parts of July as well. Right? Some parts of August as well. Okay? So it takes the planet around 6 months to come in these positions, because overall one complete rotation will take how much? 1 year. So from this location to half a revolution, how much it will take? It will take 6 months. So that is why you have a distinct summer and a distinct winter season. because the tilt is the same. It is the position of the planet which is changing. Now, think about another scenario. Think about a scenario whereby when we talk about the planet is situated here. In the sense, think about it right to the back of the sun that we cannot draw. So we are drawing it like this. Okay. And this has been the movement of the planet from here till here, right? That has been the movement. Now, this is the location that the planet reaches in the month of September. Now, the tilt of the planet is the same. Tilt never changes easily. So the tilt of the planet is the same here, isn't it? This is your equator. Now here, now listen to this carefully and try to understand this carefully. Suppose this is where the sun is, right? Position 1 is here. Position 2 is here. Let's assume. Now we are talking about a new position on the side of the sun. The tilt is present. But if we consider that the solar rays which will shine upon, now the solar rays, they are shining upon a direction which is completely different to the direction in which the tilt is present. So at this point of time, the solar rays, they will be able to light up the entire region. Don't think about it as if the earth is sitting on top of the sun. Even though the image exhibits something like this, let me take you to a kind of a sorted image overall. Think about it with the help of this image if you can. So basically, this is the position 2 that we had seen. We had also seen a position 1. We had also looked at a position 1, okay, where you had the tilt like this. That brought winter in the northern hemisphere and summer in the southern hemisphere. Now, if I take this position, or if I end up drawing this position, now the tilt is still going to be in the same direction. But if I consider which part of the planet will receive more sunlight, the northern hemisphere or the southern hemisphere, what do you think will be the answer in this case? Which part will receive more sunlight, or will they end up receiving equal amount of sunlight? What do you think? Suraj, Aman, Prithvi, Molly, Sahil, Abhishek. Very good. Kagan, Rahul, most of you. I'm sure few of these names. So it takes me a couple of classes, guys, to get a hold of your names as well. So please bear with me. So it is after 2 to 3 classes where I'm able to figure out, as is the case with all the teachers as well. It takes them 2 to 3 classes by which we are able to figure out that who is the one who knows something and who is the one who has lesser amount of clue, right? So here, as most of you have given the correct answer, the solar rays which basically are given, they will shine equally on both the hemispheres because the angle of the tilt is in a different plane as compared to the angle of solar incidence. So here, both the hemispheres get equal sunlight. Why? As the tilt is in a different plane as compared to the direction of solar rays coming in or solar light coming in. So if let's suppose this is the sun, this is the direction in which the rays are coming in, this is the position of the planet, this is the position of the planet. Imagine this position in a way where this is the axis, the tilted axis that we have been talking about. This is the axis, right? This is your equator. So overall, the tilt is in this direction where the rays are coming from the other direction. So both northern and southern hemisphere, they will end up receiving equal amount of solar rays. Then this position is something which is achieved in the month of September. Right? That transition from summer to winter, that is what is also referred to as autumn. So it is during the autumn season where you experience equal length of day and night, because both the hemispheres, they receive equal amount of sunlight. Now that position, after this in winter, you will also experience that you have a kind of a similar position in the month of March as well. Now in this case, which will receive more sunlight? Is it the northern hemisphere or is it the southern hemisphere? What do you think? Good. Very good. Here also, both the hemispheres will receive equal amount of sunlight. For those of you who are unable to think about it or who are unable to imagine it, I don't have a globe in my hand as of now. But think about it. Suppose this is the planet. It is at a tilt, right? Let's suppose this is the tilt. Now here, it is moving with respect to this pen which indicates the sun. Now here, as long as you have this phase experiencing the sun, you can have some areas getting less light, some areas getting more light. If it is here, some areas will get more light, some areas will get less light. But if it is here, then both the areas or the entire disk will end up receiving the same light. Similarly, if it is here, the entire disk will end up receiving the same light. So that is the entire process at play, which gives rise to various different seasons as well. Okay? That is how both of them will get equal amount of rays. Why do they get equal amount of rays? This is the reason that I have written. Okay? Is this clear? Yes, Earth is revolving. That is why the Earth is able to reach at these different locations, isn't it? What is revolution? Revolution is movement around the sun. Is this portion clear with regards to it? Very good. Now, when we talk about the movement of Earth around the sun, that is where we'll come to these seasons as well. When we talk about the movement around the sun, the movement does take place in a kind of an elliptical orbit. It is not circular, it is elliptical. I hope that we are aware that there is a difference between a circle and an ellipse, right? A circle appears to be somewhat like this. A circle appears to be somewhat like this, whereas an ellipse will give you an appearance somewhat like this. So if you consider planet Earth to be like this, and this is the sun, this is the planet Earth. So here, the planet moves around the sun in an elliptical orbit. This is what is elliptical orbit. So, if the planet moves in this manner, automatically, there will come a position where the planet is going to be closest to the sun, and there is also going to be a position where the planet is going to be farthest away from the sun, isn't it? If it would have been a complete circle, then at all places of rotation and revolution, planet would have been equidistant from the sun. But when we consider an ellipse, thereby the planet is placed at different distances. There will be one day of the year when the planet is closest to the sun, and there will be one day of the year when the planet is farthest away from the sun, isn't it? Similar is the case when we consider the planet Earth and the moon moving around it. Now, Earth has moon moving around it. So even in the case of Earth and moon, there is a day when the moon is closest to the Earth, and there is also a day where the moon is farthest from the Earth. So you have a technical terminology which is used for these different positions. When you have the planet Earth situated at the farthest distance from the sun, the day when the planet is farthest away from the sun. And when we say the farthest, that point of time, the distance is roughly around 152 million kilometers. Subsequently, there shall also be a day when the planet is closest to the sun, and that distance is what is around 147 million kilometers. Okay, so that is where, when the earth is farthest away from the sun, that is what is referred to as aphelion, and that position when the planet is closest to the sun, that is referred to as perihelion. Now, aphelion and perihelion, it is made by joining two terms. So you have helion in both these cases, which refers to the distance that you are measuring. You are keeping sun as a point of reference, right? So ap refers to something which is far, peri refers to something which is close. That is why aphelion and perihelion, we are measuring the distance with respect to the sun. So this date of aphelion, this is observed on when? Roughly around 4th of July. And then when it is closest to the earth, that is experienced when? Roughly around 4th of January. Very good, guys. Okay, that is the aspect of aphelion and perihelion. So if someone asks you, what do you understand by aphelion? Or if a question comes that at aphelion, the distance between the sun and the earth is the minimum, true or false? It is false, because the distance is the maximum. Similarly, when we consider the moon's movement around the earth, moon will have a position closest to the earth, and moon will also have a position farthest away from earth. Now here we are measuring the distance between the moon and the earth. We are not considering the sun at all. Now, earlier when sun was the reference point, we could use the term helion. Now, when earth is the reference point, what is the term that you use? You use the term G. So when the moon is going to be farthest away from the earth, you will attach the same prefix, that is apogee. Moon is farthest away. When moon is closest from the sun, that is when you will attach the same prefix, that is peri. Here, the term G is used referencing earth. Reference to earth. Helion is what refers to the sun. Helios is from where the name is derived from. That is where you have the element name helium also derived from, because in Greek you had the term for sun as helios. So that is from where heliocentric, helion, etc. That entire terminology has been derived from. That is where the origin lies. So this is the definition aspect. So Earth at its maximum distance from the sun is at aphelion, and at its minimum distance at perihelion. Right? The point in the moon's orbit where it is farthest from the earth, that position is apogee, farthest. Farthest here also is ap. Here also farthest, you attach ap. Then when it is closest, that is referred to as perigee. Okay, so when the moon is closest to the earth, that is the situation of perigee. When it is farthest from the earth, that is a position we refer to as apogee. Okay, now then here we come to why we experience seasons on the planet. So basically, here we have seen the different positions of the planet. Now, let's suppose I mark the positions slightly differently. Let's suppose I mark it 1. Let's suppose I mark it 2. I mark it 3. And this is the position I mark as 4. One by one, we shall try to analyze what are the conditions which are prevalent during these times, right? So we start with this position 3, that is here in the month of November. Now, in this image, this is where you experience the sunlight coming in, sunlight. This is where you have the rough equator which is present. I hope you are able to see the axis and the polar region as well. This is the polar region, right? This is the Arctic Circle, right? This is somewhere the Antarctic Circle will be. Now, if I draw the circle of illumination here, circle of illumination in very simple terms, what distinguishes daytime and nighttime, that imaginary line. So here, basically, if I do this, this will be my circle of illumination. Now pay attention carefully. I'm going to ask questions here. Now, here we have seen that the equator divides the planet into two parts. You have the northern hemisphere and the southern hemisphere. Okay. Now, if you observe here, which is the portion, northern or the southern hemisphere, the same exercise, which is the one which is going to receive more amount of sunlight? Let's repeat that exercise. Beautiful. Southern hemisphere. So, more light. The questions don't end here, so think about it. Wait for it. I'm leading you to the understanding. So, more sunshine means summer season. Northern hemisphere, comparatively, if you observe, only a small portion of it experiences sunlight, and in one rotation, very quickly that portion will again be hidden in darkness. So in these conditions, you will have longer nights and shorter days. So less sunlight, less sunshine, and that is winter season. Now, what about the Arctic? The Arctic Circle, that is the region of North Pole and the nearby areas. Now, if you observe this region and analyze this location, think about it. In this position, if the planet continues to rotate even endlessly, still, is light able to reach the region of North Pole? Absolutely not. Why? Because the position is such that the portion of North Pole is hidden from solar rays. Regardless of how many rotations take place, sunlight will not reach there. Now, what about the South Pole? South Pole. Now, here, that is the region of Antarctica. Now, in the region of South Pole, what do you experience? Do you experience nighttime here? No, because the entire region is illuminated, even though by tilting solar rays, but nonetheless, solar rays which are present. So that is when, for the entire duration that the planet is in this location, the North Pole will experience a complete darkness of sorts. Whereas the South Pole in that entire position will experience a complete daytime. It will not be as bright as your daytime sun around 12 noon or 2 p.m. No. It will be very much like the early morning sun that you see around 7 a.m. or 8 a.m. That is the type of the sunlight that will be received at the region of Antarctica. So now, whatever we have seen till now, let us compile it. Why? So that after the classes, when you forget it out and when you sleep it out, maybe when you wake up after 2 months or 3 months, and then you realize that, okay, I had a subject, that geography, that I managed to attend, I need to revise that as well. So let me write it down in compilation so that your task becomes easier at that point of time. So the months, which months are we talking about? We are talking about the months of October, November, December, January, and February. That is when the position is in that kind of pattern that we have seen. So, in the case of Northern Hemisphere, you experience shorter days and longer nights. That means it is winter season. Right? When we talk about Southern Hemisphere, that is when you will experience longer days and shorter nights. And when the daytime is very long, what is the season we experience? We experience a summer season. Summer season. Now, what about the polar region? So, if I consider, let's say, the region of North Pole or the Arctic Circle, let's consider the region of Arctic Circle. Here, you will experience continuous night or sun does not rise above the horizon. By the way, how many of us are not aware about the meaning of the term horizon? So, for those of you who are not aware about it, so it is a kind of that imaginary meeting point of the sky and the ground. So when you look out your window, when you look out into the sky, you will observe that the sky appears to meet the ground, meet the ground somewhere very far off. And when the sun rises, it basically rises up from that point and eventually sets there as well. So that is what is referred to as horizon. So we can say sun doesn't rise above the horizon. What about the region of Antarctic Circle? This is where you will experience continuous day sun doesn't set below the horizon. It is continuous. It will not give you much heat, but you will be able to see the sun. Now, it is for the entire duration that you experience the position of the planet somewhere across this area. In that entire area, as the planet moves, you experience these seasons. So, the peak position of the planet, where you will have the tilt in a way that northern hemisphere appears to be tilted away to the maximum extent, that is something which is experienced in what we refer to as the winter solstice in northern hemisphere, or the December solstice. 21st December, that is what is referred to as December solstice. Now, in this case, you have the peak positioning, so that the northern hemisphere appears to be tilted the maximum away and southern hemisphere appears to be tilted maximum towards. So, in this case, northern hemisphere will have shortest day and longest night. And the southern hemisphere on this day will experience longest day and shortest night. Solstice is a name associated, it is very much a part of European cultural traditions. And when we talk about the aspect of solstice, this is where that particular day used to be celebrated in many ancient customs and cultures in order to celebrate the longest day, right? And the shortest day. They would celebrate it because, as per them, that is when the position of the sun would change. So, that is where the term solstice has come from. So, don't think about the multiple implications of solstice, just understand this is what is also referred to as winter solstice in the northern hemisphere, because it is winter in the northern hemisphere and it is summer in the southern hemisphere. That is why it is referred to as the summer solstice in southern hemisphere. Okay. Yes, Shamil, that is very correct. Okay. So that is what happens at the peak position on 21st of December. That is when the position is such that the tilt gets accentuated in a way that the northern hemisphere is farthest away. If the planet's position had been anywhere else, if the position is here or here, the length of the day and the night would vary. It is here where you will have the longest day for the southern hemisphere because it receives maximum exposure towards the sun. Then we come to a situation close to the month of March and also the month of September. By the time that you come to the month of March and September, March and September, in both these cases, when is it that which position are we talking about in September? This is for the month of September and this is for the month of March. So if you observe these positions, you will observe now this is February. By the time that March comes, the axis is somewhere here. And the solar light is coming here. So when the axis is like this, the equator will be somewhere here. So in this case, both the northern hemisphere as well as the southern hemisphere, they get equal amount of sunlight. So that is when these are the conditions which are referred to as spring in the case of March, autumn in the case of September. Generally, when you transition from summer to winter, thereby you get a transition season, if you would experience, where it is neither very hot nor very cold. That is what is autumn. And when winter and the cold conditions they start reducing and the summer conditions they start increasing, that is when you experience the spring conditions. So in both these cases you experience moderate climatic conditions. In these cases you have equal length of day and night. Equal length of day and night. That is referred to as equinox. Right? Now, this exact equal length of day and night, this is observed on two dates. First, which is coming closer to us, that is 21st March. Very good. And then in the month of September, you have 23rd September. So that is when you experience what is referred to as equinox, because you have equal length of day and night experienced in both the hemispheres. The axis is not straight here, Vijay. Axis is still tilted, but axis is tilted in a direction which is different from the direction that the solar rays are coming in, right? Earlier, again I will repeat it, think about it. Suppose my hand represents an axis, right? Suppose this is the axis. So this will be the portion of northern hemisphere, this will be the portion of southern hemisphere. If the sun is shining from here, can I not say that northern hemisphere is getting more light, so summer season, southern hemisphere is receiving less light, so winter season, if the sun is here, right? But what if the position is such that the axis is like this and the sun is shining from here? The axial tilt is still maintained, but then both the northern and the southern hemisphere, despite the tilt, will receive equal amount of solar rays. So that is where you have the equinox conditions. Okay? Right. No, it does. Yes, correct. Then we come to the month of what we refer to as the summer season in the northern hemisphere. This is the sunlight. This is the sunlight. Okay, by the way, how many of you have no clue what is Tropic of Cancer, what is Arctic Circle, what is equator? How many of us are not at all aware about that? Those of you who know, please don't write it. Those of you who have no clue. Okay, more than what I expected, to be very frank. But it's okay, we'll cover that. That is something which we should know ideally. Okay, no issues. We'll cover that. Don't worry. Now, basically, if we consider this position of the sun, right? The which position of the sun are we talking about? We are talking this position of Earth rather. We are talking about this position when the planet is at this particular position. Now here, if you will observe, then in the figure, this is the axis, this is the tilt, this is the region of the Arctic Circle, or rather, don't think about what I am saying as Arctic Antarctic Circle. I hope we are aware about the equator. Equator is the line passing through the central portion of the Earth, which divides the planet into two equal halves. You have the northern hemisphere and the southern hemisphere. I hope that much we are aware. So let's drive with that itself. Let's suppose this is the equator. Now here you have the North Pole. Here you have the South Pole. Right. Now, if I do the same exercise in the case of Northern Hemisphere and the case of Southern Hemisphere, can I not say Northern Hemisphere in this position is receiving more amount of sunlight? I can say that. So that means summer season in the Northern Hemisphere and winter season in the Southern Hemisphere. So during the months, which months? During the months immediately after March, that is the months of April, May, June, July, and even August. During these months, you'll find the planet in this position. Which position? Again, I will take you back to this image. That is, as soon as the planet enters here or here or there or here, so you will always have the same conditionality of the tilt. So the northern hemisphere will appear to be tilted towards the sun. In these positions, the northern hemisphere that appears to be tilted away from the sun. So when the northern hemisphere is tilted towards the sun, in that case, in the northern hemisphere, you will experience longer days and shorter nights. And that is where you will experience the summer season. Okay? And in the southern hemisphere, you will get shorter days and longer nights. That is where you will experience winter season. Right? Now, what will happen at the region of the poles? Let's forget the Arctic Antarctic Circle. The poles through which the axis passes through, those are the poles. So the North Pole, you will find, is consistently receiving sunlight, isn't it? So around the region of North Pole, you will experience daytime, whereas when you observe the South Pole, it is hidden behind the circle of illumination. That is, it will experience nighttime. So in these months, during these conditionalities, the region of North Pole, continuous day, or the sun does not set. Whereas when we talk about the South Pole, that is when you will experience continuous night or where the sun does not rise. And then 21st of June, just like 21st of December, you have 21st of June when you experience the peak position, which is also referred to as June solstice or summer solstice because it is summer in the northern hemisphere. So that is where June solstice, that is where in northern hemisphere, now you will have longest day. Longest day. And in the southern hemisphere, you will experience shortest day. Okay. So that is how, just owing to the location of the planet as it is moving from one area to the other, that is how you get an experience of all the different seasons in that region. Okay. Now, that is the very basic about rotation and revolution. something that I don't know what is the course curriculum nowadays, but I remember this is something that used to be taught in around fourth or fifth standard. I'm not sure if it is being taught right now. How many of you have not read about this rotation and revolution of the planet in your school? Let's be frank with each other. We are going to know each other much more in greater detail in the coming days. How many of you have not been taught about this in the school? Okay. Chalo, at least nobody is brazen enough. Few of you are saying that it has not been taught in the school, but at least you are honest enough. Right. Okay. You have no idea. Oh my God. That is even worse than not being taught, because if someone says I have no idea, that means it might have been taught but would have been completely lost from my mind. Okay. Even if you are from medical background, come on, don't give me that excuse. It is not as if the engineers are supposed to read this. This is something, even if you are in medical background, you would have diversified your course after class 10th, isn't it? And this is something that you read in class 4th or 5th. So please don't give me that excuse. I have also been a backbencher in my life, so please, those excuses also don't work, that I have been a backbencher. So that is where. Right. Yes, Abhishek, that is very true. Now, this is where, after this, we come to another basic thing which would have been taught in class 6th or 7th, regardless of whether now you are in medical background or now whether you have become the prime minister. Again, this would have been taught in your school. That is about latitudes and longitudes. Okay, so let us basically try to attack this particular portion, that what do we mean by latitudes and what do we mean by longitudes. First of all, why was there a need which was felt for this latitude and longitude? I hope one thing that we are aware of, even if we are not aware of, both the latitudes and longitudes that we see, these are basically imaginary lines. These are not real life or real time lines that you can see on the ground surface. These are very imaginary lines. So when we talk about these imaginary lines, basically the latitudes per se, they have been in use for thousands of years. In fact, the ancient Greeks, they are said to have been using the idea of latitudes in order to navigate from one area to the other. When they wanted to move from one area to other in the all these oceans, at that point of time, compass was again something which was not available. So people used to move with the help of the alignment of the stars and the sun and the moon. So their movement, they used to chart out with the help of an imaginary line. That is what they refer to as latitudes. Then came the issue of timekeeping. For example, when we suppose we are, and right now we are in India, and suppose you have your friends in, let's say, London, or let's say Berlin, Germany. Now, what time we experience here in India, will we experience the same time in Germany? Absolutely not. The We know that the planet rotates from west to east. So which will receive sunlight first? Will it be India or will it be Germany? If we are attacking the basics, let me ask this basic question. Who will receive sunlight first? Will India receive sunlight first or will it be Germany? Obviously, it will be India, as the planet rotates from west to east. So there was a need which was felt in order to have a reference time, that if it is 5 p.m. in India, we need to know what is the time being observed in Germany as well. So that is where, for reference purposes, you had the drawing of imaginary lines which would join the north and the south pole. And these are also, in fact, circles running across the planet. They are meeting at north and south pole, right? If you think about a circle, you can basically end up making different angles, they're different circles. In the case of the planet Earth, let me give you the example with this. Suppose this is a sphere. So you can draw a circle somewhat like this. It will pass through here, go through the back. You can also draw another circle like this. It will pass through here. It will go through the back. So like this, you can draw many circles. Now, each of these circles will give you an idea that what is the time observed there, because the planet is going to rotate from west to east. So here you will receive sunlight early. Sunlight is early. Jasmeet, my dear friend, the moment you feel that the class should end, it will end at that point of time. You just have to close down the session. Okay? So please don't think about it that till when do I have to carry this burden. The moment you think that it is too much, end the session. No harm, no foul done. Okay? Now, that is why the entire aspect of imaginary lines, they came into the picture, and that is why the imaginary lines were drawn out. Let us take a look at each one of them. Let us try to understand what they are. So we start with the latitudes. First of all, what are latitudes? Latitudes are basically also referred to as lines of parallels. These are parallel circles which move or which are drawn around the planet. So this is the image of the latitude. So you have these as the latitudes. Now all these lines are basically parallel to each other. Right? These are your latitudes. Now, if you have some latitudes which are important, right? They are the prominent latitudes which are present. So here, when we talk about the latitudes, the largest latitude or the longest latitude overall is the one which passes through the center of the planet, and that is the equator. So equator is where you will find the largest longitude or latitude. Great circle is very different. Okay, Shamil. Now, then you have the latitude which passes through Tropic of Cancer, and that is at 23.5 degrees north. So that latitude is referred to as Tropic of Cancer. This is 23.5 degrees north. Then the latitude passing through 23.5 degrees south, that is what is referred to as 23.5 degrees south. That is known as Tropic of Capricorn. Why that name? Tropic of Cancer, Tropic of Capricorn. Why that name? These are basically named after the position of the stars. Cancer, then Capricorn. These are basically the stars and the constellations that you observe. So, according to that, when you have the viewership or when you have the angle which is decided, that is how the Tropic of Cancer and Tropic of Capricorn, that naming was given. Now, here, the 66.5 degree north latitude, that is what is referred to as the Arctic Circle. That is referred to as the Arctic Circle. And the 66.5 degrees south, that is referred to as the Antarctic Circle. Now, how do you measure it? That what is this equator 0 degree? What is this Tropic of Capricorn 23.5 degree? What is this Arctic Circle 66.5 degree? How do you end up measuring it? So the measurement is done in a simple method, a very simplistic method. So for example, and suppose you want to measure the latitudinal extent of this P, the latitude that you have drawn, let's say P. It is an imaginary line. So what do? So you imagine of the region of equator, the equator. Okay. Now, from the region of equator, draw a line joining the center of the earth and Join it with the angle coming from the latitude that you want to measure. Now, the angle that you have measured, let's say it comes out to be 40 degrees. So, this will be 40-degree latitude. Because it is situated in the northern hemisphere, you associate the term 40-degree north. Suppose I want to measure the latitude which is present here. This latitude is what I want to measure. How do I measure this? I will put a point R. I join this with the center. I measure the angle. If the angle comes out to be 30 degree, this will be 30-degree south. So that is how you have the measurement of latitudes which is done. What about the polar region? The poles. Now, in that case, if you join it with an angle, it will make how much angle? 90-degree. So that is why the North Pole is 90-degree north. The South Pole is referred to as 90-degree south. 90-degree south. These are what we refer to as latitudes. I have put in the definition aspect as well, right? Many of us are very fond of definitions, even though definitions are not at all important for your civil services examination. But still, many of us, amongst you yourself, many of you start getting restless. That fair enough, whatever you have taught through the day, are you giving that to me in writing or not? That is all that I'm concerned about. Rest of it, you can keep it with you. So that is why I have provided the written portion as well, so that some portion of that is satiated. So latitudes are imaginary circles parallel to the equator. On a map where north is up, latitudes run laterally, right? They are named after the angle created by a line, imaginary line, connecting the latitude that you have to measure and the center of the earth, right? You have a line that we made and the line connecting equator and the center of the earth. That angle that you make, that is how you end up measuring the latitudinal angle of a place. Okay, right? So this is in order to get to know the locational aspect. That is why latitudes were brought into purpose. For date setting, for time setting, and time referencing, that is when the longitudes came into inception. And this was basically something which started gaining momentum in the 1800s. Because by the 1800s, the world was growing smaller, in the sense that not the size got smaller, but now people could travel from one region to another quite easily. So that is where you had a lot of correspondences and interconnectivity happening across various places of the planet. Now, suppose someone in China wrote a letter to someone in London that this event occurred at 5 p.m. Now, how would you know that when it is 5 p.m. in China, what is the time in London? How would you associate with that? So that is where, in order to have a reference of date and time, the Postmaster General of London, at that point of time, the British Empire in the 1800s, I'm sure all of you have studied modern history and you're fresh from the portion of modern history. So you would have studied this, that in the 1800s, it was the British Empire which ruled them all. In fact, it was said that sun never sets on the British Empire, because at all point of time you had various different areas under the rule of British Empire who would experience daytime. That was their spread, that was their power. So the Postmaster General of in London, obviously an important post, so he decided to make the referencing for time. So what he did was, the longitudes which were present, he started using them as the reference for time. And he chose the longitude passing through the Royal Observatory. Royal Observatory of in UK. That is the main research center which has been carrying out astronomical researches for hundreds of years now, a couple of 100 years and more. So you had a longitude passing through the Royal Observatory near London in the region of Greenwich. So you had longitude passing through Royal Observatory, where Greenwich, near London. Now this longitude which was passing through this, that was selected as point of reference. And that point of reference, this was referred to as prime meridian. Okay? Now, each of the longitudes, they will represent one angle. So if suppose I give you a view from the top, let's suppose we are looking at this from somewhere here. Now, if you look from there, let's suppose this is the North Pole, right? So, how many longitudes in total you will have? Each of the longitude represents how much? 1 degree. Let's suppose each of them, they represent 1 degree. So, in total, how many longitudes will you have? Neil, you are partially correct. So, in total, you will have such 360 lines, isn't it? So, overall, you understand that the complete circle which is drawn passing through the North and the South Pole, that is a longitude. The half of it that is drawn, that is referred to as meridian. So half of the longitude is a meridian. The complete circle is a longitude. So if you consider this to be prime meridian, let's suppose prime meridian. Now this prime meridian was chosen as the reference point. So being a reference point, it was allocated 0 degree. So this will be 1 degree west, 2 degree west, right? And so on. Accordingly, it will go. We are taking a look from the top view. You will have 3 degree west and so on. What will be the angle made here at this position? What is the angle which is made? Very good. This will make 180 degree. This is exactly to the opposite of prime meridian, isn't it? So the line which is exactly to the opposite of prime meridian, that is what is referred to as anti-meridian. And this represents 180 degree. Right? So accordingly, you have 1 degree east. Now the longitude passing through the prime meridian, just like equator divides the planet into northern and the southern hemisphere, longitude passing through the region of prime meridian, it divides the planet into eastern hemisphere and the western hemisphere, which is present. So that is what you get as longitudes. Now, how do you measure the longitudes? By a very similar method that you observe in the case of latitudes. In the case of latitudes, what did we do? We joined an imaginary line from the longitude that from the latitude that we had to measure and joined it from the line coming from equator, and we measured the angle. In this case, suppose I have to measure the angle of this longitude. Let's suppose I have to measure the angle of this longitude. And this is my prime meridian, which is referred to as 0 degree. So what I will do is, I will draw an imaginary line. I will join it up with another portion of prime meridian. I will measure the angle. Let's say this angle comes out to be around 120 degrees. Now, as compared to the prime meridian, It is 120 degrees to the east or the west, to the west. So this will be 120-degree west longitude. That is how you have the calculation of longitudes overall. Okay. So that is where we'll end the session, guys, here today. We meet on Thursday again. Tomorrow, I guess, is a holiday because of Holi. So, a happy Holi in advance to all of you. We meet again on Thursday, and that is when we initiate our real discussion on the portion of geomorphology. This is a kind of an introductory class, right? So, don't get entangled in these basics. If you are unable to understand about it, read the basic first chapter of any book of geography. You will find this. If you are unable to find it, look at the books of class 6, maybe class 5 also. In certain cases it is present. Just take a look at that. You will get this easy information in your mind. We meet again on Tuesday, and that is when we start the serious stuff. So till that point of time, take care of yourself. Have a happy and a safe Holi for all of you. And then a couple of questions we will take. How to calculate the longitude? Longitude is basically calculated, Nandini, by measuring the angle made by the prime meridian and the longitude that you want to measure. So you join these, connecting it to the central point of the planet, and that is how the angle you measure. Okay, how can we say that the Earth is tilted? We know that the Earth is tilted because see, if the planet had been like this and rotating like this with the two still points immediately vertically, we would have said there is no tilt. But the planet is rotating as a sphere with 2 points or the 2 poles at a tilt which are not rotating along with it. So that is where we say it is tilted. Okay. Tomorrow is no class now. If I measure this angle to come out to be 120, Risha, so then basically that is something which creates a 120. See, 120 will be where? If I end up measuring this longitude from, let's say, if I measure this angle, it will make 120-degree. So this will be 120-degree longitude. Okay. We have to write answer by using diagrams always, always. As the perihelion falls on 4th of January, during which time there is summer in the southern hemisphere, but the first sun is farthest during summers in the northern hemisphere. So my question is, are summer harsher in the southern hemisphere? No, not really. It is the summer conditions and the winter conditions. They are more or less balanced out by the atmospheric conditions that you observe. So distance from the sun becomes a minuscule fact. Let us come to the portion of climatology. We'll talk about it. Can we use stencil in the mains examination, my dear friend? If you have enough time, fair enough. But if you take a humble suggestion, an honest suggestion, you don't get enough time to write about it. Pritam, please try to revise what you have studied till now. Initial days, Pranay, it will take more time. Slowly and steadily, it gets easier. Harshita, Milankovitch cycle. See, if we are finding the very aspect that the planet is rotating around the sun, if we are finding that aspect difficult, let us try to push Milankovitch cycle to the side. First of all, let us understand something which is very, very basic. Okay, because many of us, I'm sure, have no clue that what is equator, what is the Arctic Circle, what is the Tropic of Cancer. And if I throw at you the aspect of Milankovitch cycle, I'm sure you will lose all the bearings. So let us stick to that. Ravendra, that is true. The seasons are due to the tilt. Unnati, equator is one of the great circles. There are many great circles across the planet. Latitude we measure by measuring the angle Devansh from the region. So this is the written portion, and this is where you will observe that whichever longitude latitude that you have to measure, you join it with the equator, joining it to the center of, suppose I want to measure this longitude, I will join with an imaginary line, I will measure the angle it makes with equator, and I'll get the answer. Uh, can you explain again what is June solstice? June solstice basically is the position of the planet on 21st of June, where the tilt is fell to the level maximum in terms of the location of the planet, and that is where the northern hemisphere gets extraordinary larger amount of or larger duration of sunshine, and that is why we have the longest days on 21st of June in the northern hemisphere. And because the northern hemisphere is tilted so much towards the sun, the southern hemisphere will be tilted away, and you have shorter days and nights. Okay? Yes, Suparno, that is correct. Another longitude. Which another longitude that you want? Rachna, what is the doubt? I can draw endless number of longitudes. This is relevant for your prelims. Subarna, how India gets sunrise earlier as compared to Germany. Okay, my dear friend, what I would suggest to you basically is take a look at the planet. Get a globe if you can, if it is logically or if it is feasible for you. Get a globe, even a small one. Look at the relative positions of the various countries. So the planet rotates from west to east, and Germany is situated on the west of India. So obviously, as the planet is rotating west to east, if sun is here, it will experience sunlight at a later stage, right? And that is why the sun rises there later. India is situated to the east of prime meridian, my dear friend. Okay. Okay. So that is where we'll restrict the session here, and we'll start again on Thursday. Kindly look at the portions that you have covered till now. Please read it up. If you want to improve in the subject, please read it up. Get back on Thursday, where we start the portion of geomorphology. So that will be all from my side. Till we meet again, take care of yourself, have a safe Holi, relax, and then we meet again. Good night. Take care of yourself. Thank you.